to realize that 100% is what we should go for. But we all know the arguments why we should go for 100% renewable energy. The environmental effects of using fossil fuels and nuclear are known, and the energy streams of nature, of the planet, is available everywhere. Even in the Arctic, there are some resources available. Sometimes we don't think about it. I saw a company that has always also delivered a windmill here, this Poulsen windmill. They are advertising they have windmills in Antarctica. So it's possible to use renewable energy everywhere in the world. So we can provide people with energy all over the world, and the potential is also for decentralized production. And I think that, in my view and in our view in INFORSE, that's really important, to have decentralized possibilities in production. So poor people shouldn't be depending on being able to buy energy from big transnational companies that just own the electricity grid and the electricity production. Renewable energy can, in our opinion, and with the calculations that have been made, the scenarios that have been made over the last 40 years, cover the consumption of everybody physically. We have all the resources. This one shows a lot. Lisa was using it yesterday also. We have the energy consumption of the world in 1 year here, and we have the total amount of solar energy on the planet for 1 year. So you can see that we can cover our energy needs thousands of times. It's just a question of finding the technology and finding the will also, because we have interest that wants to continue burning fuels of different kinds. But we have the resources, so whenever people say we don't have enough renewable energy, they don't know the facts. The physical facts are that we have enough renewable energy for everyone forever. As long as the sun is maintaining life on Earth, we have enough energy. So let's look at a little country in Northern Europe and see how much energy we can. I have to be careful with this. Every year, the sun delivers 150,000 units. PTU is just a unit used for the statistics, so we don't have to care about that. Of renewable energy, of the sun only. Don't think about wind energy or something. The sun radiation alone is 150,000. And our energy consumption is when we look at how much we use and not how much we burn, it's around 680 units. So this means we can actually, in Denmark, we could cover our total energy consumption. And that's everything. That's for electricity, heat, transport, industrial processes. That's for everything. Cover it 220 times in Denmark with the sun alone. So don't believe and a real example from a Swedish home that was built by a Swedish engineer, where he's self-sufficient in all kinds of energy for his household, including transport, using only solar energy, only PV, and solar heating, and then he have a battery, an electrolyzer, hydrogen storage, and a fuel cell to use the hydrogen, make electricity and heat from the hydrogen when the sun and the battery doesn't deliver. So that can be dark in winter time. But this is to show that it is possible to do it technically. We have already the technology to do it. We have the physical resources, as I pointed out, and we have the technology. So we can do it today. We don't have to invent some technology in 10 years or something like that. It is actually possible. This is history. 40 years ago, in this energy plan, these scientists from Danish universities, they made a calculation. If we use the energy more efficient with the well-known technology we already have, and become more efficient, and we deploy more renewable energy, they said that we could reduce our energy consumption, and we could cover it with solar, wind, some bioenergy, and a bit of gas. So this would be biogas. But coal and oil that Denmark was totally reliant on in 40 years ago could be phased out. So already at that time they knew that estimating the technology that was available, it could be done. This is a scenario I would encourage all of you to look at, also because you can look at your own country. This is a US-based, some scientists at in Stanford University in California made these calculations about the physical resources and about the technology available today, not in 10 years or 30 years or something like that, but the technology today. And this is the example for Denmark. You can find example for 140 countries all over the world. There are just a few countries where the statistics are not available. So this shows that, sorry, I need to look at this before I push the button. Shows that wind could play a big part in Denmark, in the Danish energy mix. And why we use so much wind is of course we need more energy in the winter time. 40% of our energy need is for heating, and it's in the winter time. Right now we don't need anything for heat, any energy for heating. So that's why wind energy is genius, because we can also use it to supply the heating in the winter time. We have the resources. We have windmills, we have biomass energy, solar heating, and solar power, and we can use some biogas. In my view, and in a lot of Danish environmental organizations, we should use only the biogas that we can produce from organic waste, and we don't think that the agricultural production in Denmark right now is sustainable. We import too much fodder and from all over the world and produce too many pigs. because we need not only to have on a yearly basis, but also hour by hour electricity and heating. This is from this kind of calculations, scenarios that has been made by both NGOs and university people, and the Engineering Society in Denmark has been made using the same model. Where you can look at the energy needs for each hour in Denmark in a year, and then calculate how you could cover it. So you see the electricity for a week in April as an example. We have a lot of wind power, some wave and solar power on top, and some imports during this week. There are some imports, mainly from Norway, where they have a lot of hydropower. And we're looking at the need for heat. Solar heating and heat pumps will cover. And there are some contribution when this week there wasn't enough solar energy, so it seems to sometimes it was necessary also to use some combined heat and power production with some gas engine that could run on biogas. So these calculations has been made. It's possible for every hour to cover the needs. And it will be cheaper than to use a fossil fuel system. You calculate the prices and the costs of fuel. This was even made before the latest rise in fuel prices. You can see that it's cheaper. These are the ones with 100% renewable energy. And this is the basics calculated with low energy prices, and this is with higher energy prices from the official Danish state calculations. The Danish Energy Agency made this prognosis for the energy system. And these are some of our partners. We are very keen on getting community energy and community ownership, decentralized production. So this is some of our partners in Denmark, and of course the Folkecenter is also included. We're closely together on that. You can find more information on some of these things, and of course I'm available and the magazines are available, so you can have the web addresses for today and next week. Just a few things about Europe. Have I passed the time or something like that? Okay. Because actually there have been studies about how much citizens could take part of the transition of Europe to renewable energy. We are fighting a fight with our coalition partners from other NGOs and environmental NGOs in the European Union, and also nationally in Germany. There is also a big movement for more community energy, I know, to make the politicians realize that it doesn't have to be big transnational companies that should own all of our energy production now and in the future. Actually, if we are allowed, normal citizens, normal people can contribute, and we are willing to invest. Even if we don't have much money, we are willing to invest €1,000 or something like that in energy. by an institute in Holland, in Delft, the CE Delft, and here are some of the conclusions. It was commissioned by a number of the European environmental NGOs, and the big conclusion is that a big part of the citizens could be involved in producing electricity and could produce about 45% of the electricity needed in 2050. So they also say that this is impossible. Individual households could be producing, and they could do it together in communities and public entities, municipalities and so on, and small enterprises could be producing their own and for others. Photovoltaic and wind energy could be used, and the demand side also could be a good thing to control and to make better. But the conclusion is that approximately one over two people in the European Union could produce their own electricity if they were allowed to, and the framework from the political side were all right. A big part of the households could become energy citizens and contribute to energy production or demand side regulation. Use less energy when there's less renewable energy, and use more energy when the sun is shining and we have a lot of energy. So it's millions of people that could be involved. And altogether 265 million citizens all over Europe could be involved. And they also calculated, of course, how it could be done in different places with different kind of technology. And it's important to stress again, this is technology available today. We can use it, put it up now. We don't have to wait for some scientists to make invention and for an industry to start producing. It's available. Yeah. Two more slides. This is a Danish example. We're not going to visit on this coming tour, but we normally go to the both from Folkecenter and when we make it from INFORSE. Because this is a nice example from our municipality. At the coastline in the Arne, we have these three windmills were raised. And you'll see they're standing there next to the entrance to the harbor. There's a story because normally we're not allowed to put up windmills at the coast in Denmark. The exception is when it is on harbor area. At the west coast in Hanstholm, you can see windmills and other places also like this Arne. That's the only part of the coast we are allowed to put up windmills. That will be when it's harbor area. These three wind turbines were put up more than 10 years ago now, and they were invested by a local foundation for 80% and 20% for local citizens in the town of the Arne. And they provide provided the harbor with some income as well, because they rent the land from the harbor. You could also buy the land and give some income to the harbor or to farmers in that way, but renting is a possibility. And there was an obligation to make this to make the surplus stay in the community. It has to be spent on investment in the local development, and that's a really important thing all over the world, I think. If we can get this obligation from the producers that can earn money on wind and solar and hydropower, obligation to bring back the money to local development, to local investment. And the windmills are now owned by the local district heating consumer cooperatives. We have around 350 consumer-owned cooperatives delivering district heating in Denmark, and I know there's some later we will have something about district heating as well in Denmark. But it's quite important also to say that all of the district heating is working on a non-profit basis, and this is also important in this example, because this actually meant that last year, when the energy prices were enormously high all over Europe, the citizens of Vilsand got the last half of the year, they got the heating for free, because the income from selling energy from the windmills was so high that the cooperative could calculate that we have to pay back money in next year, have to pay back a lot of money to our consumers. So it's better, they decided it would be better to just give it to the consumers for free, the heating for the last part of 2022. So when everybody else was alarmed about the high prices, and even I was, I had a 50% raise in my town in Ramboll for heating, where they could have it for free in the Senate, because they had this community energy owned movements. So that's just what I wanted to stress. Thank you. If there are time for questions, we can take questions. Yeah.
One question about the percentages of renewables in a 100% scenario with respect to climate change. So worldwide, as you probably know, most of the energy for climatization is for cooling. And you pointed out that you will have a big part of it from wind, 70%, 50% onshore, 50% from offshore.
You'll be looking for the about the Danish example now.
The question was about Denmark.
Yeah.
If you have don't put the UN targets, but the real developments, if you have 5-degree warming in the 15 years or 10 with the tipping points, shouldn't the solar percentage be higher? In such a scenario where the tipping points...
Yeah, this could be changed, but they make a calculation. The Stanford University used to measure that. They would say everything is covered by electricity. So we make electricity to everything, and then from summer to winter. And
again, the question was the 5 degrees heating scenario and 5 degree more centigrade worldwide.
okay.
Much more strongly change the time. Realistically, 3.5 to 5 degree, the way we are doing now, and the projection of 10 to 15 years. This scenario was about, I assume, Stanford puts a 2 degree or 1.5 centigrade scenario into their calculation.
The amount of heating or cooling would change.
Yeah,
what was needed
percentage
on a worldwide.
for Denmark, especially.
Yeah.
But they did that.
I think that would be right. And of course, if we do more about insulation, we will need less heat. But the ratio between heating and cooling could change. But then again, if you use it on a heat pump or use your energy on air conditioning, should be about the same thing. So. Yeah.
It's a surprise to me that Stanford University has made a study where they only look at electricity and pretend nothing else.
Yeah.
Because that is very stupid. You cannot do it in efficiency. You only look at power data. And especially Stanford University. That's a huge campus. It's a big city. And there's one owner, the campus manager. He knows and sees this researchers what is best for the whole campus. Okay, the whole campus. In the same way as the city council in Denmark, they see what is best for the whole city.
Yeah.
Do you know how they heat and cool their buildings?
No.
They have a fantastic district heating and cooling system, like the one we recommend in Denmark.
Okay.
For ground source cooling.
Yeah.
You can't be done better. We couldn't have proposed it better.
Okay.
And I'm surprised to
Yeah.
me that they keep it as a secret. Because the problem of all the campuses in the US is that they have the same manager being responsible for the whole city, but 90% of them have old, outdated steam district heating.
Yeah. 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 And in a lot of American cities.
In Denmark and in Stanford, they have hot water district heating.
Yeah.
Cold water district cooling.
Yeah.
Combined that.
Yeah.
And it's much better integrated because
Yeah.
electricity.
Yeah.
That's
But this model was, yeah.
maybe it's an old model.
No, it's not. They are updating it, but they also wanted to make this calculation that if it is possible to cover the energy needs, basically in different states. First of all, in different states of the U.S. and after that, in every country where they could get the material, the statistics available, they could have about the consumption and and then they had to make some simplifications to have the model working. So they made this basically everything can be covered with electricity. You can make transport, and of course it's a future scenario. It's not, we don't have electric cars all over tomorrow, but just to their target was to show that it was possible. It is possible. We have the resources, we have the technology, and we can do it if we make a combination of energy sources. Of course, I would have more solar heating in Denmark. We already have a number of good examples in the district heating with solar energy. So we have more than 100. How much is it? 120, 130 examples of district heating with some thermal solar in it. So we should of course use that for the 20% of our energy consumption everywhere, and that could be a good combination with this heating and cooling systems. Yeah. Maybe you will tell more about that.
Yes.
Yeah. More questions?
So then we take a break now, huh? We have made some coffee and a little cake before we start up at 11 o'clock. Is that okay, Henning?
That's fine, 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 fine. Yeah, yeah.
Thank you, Henning. program, and where we are telling about Ibrahim Togola, that he will talk. That is the time where Katherine Dykes from DTU will be on the screen. She will not be here physical, so we will do it as Zoom. And all the other programs are running. As you know, we have still these little chains that we not set fire, open fire, because we are not allowed, because everything is so dry. So we will do some food by the gas grilling down here at the INFORSE Center, and it will start at 5 o'clock. So first I will give the dish to Mr. Arne Dyrelund, and he will tell about district heating system. Please.
Okay, thank you very much.
You're very welcome.
And thank you very much for inviting me to your 40-year anniversary. I'm very honored, and it's a pleasure for me to be here and to give you an anniversary presentation.
Thank you.
Because I will try to share a secret with you. Yeah. Well, we have many visitors here in Ramboll who study how we heat our cities and even small villages. And they all admit that probably Denmark is the leading country in the world as regards efficient, cost-effective and renewable energy in cities. And they often ask, how can it be? How can you do that? And do you know the secret? Do you know our secret?
No.
It's not a secret.
It is a secret because maybe we are the only country in the world who really can handle that. Maybe it's because of the Vikings. We discussed that last evening. But actually my point is that it's our agricultural reform. The farmers were slaves, worked for the manor. But all of a sudden, maybe thanks to the Viking inheritance, they were liberalized. Individual farmers, they found out they couldn't really do much with their little farm. They couldn't compete with a manor, they could produce better butters. But if they worked together, established a small cooperative in a little village, maybe inspired by the Viking age, by Grundtvig, our famous, Grundtvig, everyone knows Grundtvig, and this way they make it a cooperative and they could produce butter, same quality as a manor. And all of a sudden there were hundreds of dairies, 1,000 dairies in Denmark. And they said to themselves, well, we need electricity, why not make a cooperative for electricity? Why not make a cooperative for water supply? Why not district heating? And when you have a cooperative, you have no ambition to beat the neighbors, to supply the neighboring city, but you have an interest in sharing knowledge with them. Be open. Even let your consultant copy his project for you and use it elsewhere. This is why Danish consultants are actually among the leading in the world in this business, because they are allowed to work with these things. They don't have to sign a secret. This is a secret. Even municipalities establish a cooperative of municipalities to establish a big waste incinerator, for example. And today, all the energy sector in Denmark are owned by the consumers. Power grids are owned by consumers, distribution, the state owns the transmission. As we heard before, most district heating companies are owned by consumer cooperatives. All the cities act on behalf of consumers in municipal utilities. This is the secret. All investments in the energy infrastructure is financed 100% by very cheap loans, because the municipality guarantee for the loans. So even we have maximal competition, not only among fuels and suppliers, but also among the financing institutes. And the financial sector don't like to compete. They like to make profit. When we say district heating is non-profit, somebody misunderstanding and think, oh, it's an unprofitable business. No, it's very profitable for the consumers, because the profit criteria is to minimize the heat price. That is, gives strong incentive to make it efficient, more efficient than if you should make profit for shareholders. So this was a little introduction. Well, I come from Ramboll, and Ramboll is also a kind of non-profit organization, because we're owned by the Ramboll Foundation. And all the profit I make for my company Ramboll goes to the foundation, and they use this profit for consolidating the company and giving it for charity and other purposes. So there's no shareholders who make money on my business. It's like like if the company was owned by the employees, almost. And we have 17,000 employees in 30 countries all over the world, and we are multidisciplinary. That means we work with buildings and environment and energy and transport and management. So it's nice to be energy planner in such a company, because I can go to other colleagues and ask about how it is with that sector, so we can combine and find the best solutions for the society. We also say that we are a society consultant. As for myself, I have also actually 40-year anniversary. I have 43-year anniversary. And I will give to you a little present, digital, namely my 40-year anniversary book.
Oh, thank you.
Where I describe my experience with energy from when I was a little child, burning straw in the field. What should we else do? And playing at a landfill. and the whole transition. I just by coincidence, I shifted to the energy sector in 79. Where I was well prepared as a civil engineer in buildings and had a graduate diploma in economics, so a Ph.D. organization. So all of a sudden I was in charge of the first heat plan in Denmark to be approved by Mr. Nelson, where he approved at the same time new power plant, a CSP, and new heat plan for the city of Aarhus. Double approval. That's the first time in the world that somebody has done that. And it has been ongoing. And then I actually shifted to the energy agency from Ramboll to help Poul Nielsen to plan the district heating in Greater Copenhagen. It was 5 years of great experience, and then I went back to Ramboll. So I have also a 40 years anniversary in Ramboll, actually. That was a little about myself. But in 1990, when we have completed the big transition in Denmark, the first stage with CSP and efficient district heating in cities, then what should we do? Then in 1990, you know what happened? Suddenly the wall in Berlin was broken down, and we could go to Eastern Europe and to Russia, Soviet Union, former republics, and there was a huge demand for energy efficiency and for improving their district heating. They knew how to prepare district heating. Actually, they could do it, but it was bad quality, inefficient and leaking and so. So I've also worked in the Western European countries and seen from country to country what was the problem was, and that is why I say that what the secret is, that to let the local democratic ownership. If you don't know that, it's very difficult. If you don't use that, it's very difficult, almost impossible to establish district heating. So I have said, what should I say today? Because some of you are highly specialized in district heating, and some of you have only heard a little about it. So what should I do? I have different chapters here, so I think I will start with a light one for everybody, and then specialists can go into detail with other chapters of my presentation, which would take several hours. And I have links to some EU reports which you could study also. But let's start with the policy objectives, and see you are very happy with the EU Sustainable Development Goals, which I also am. And to make it very short, what do they say about energy? Affordable energy. First of all, affordable and clean and low carbon. Affordable means that everybody should be able to pay. We should also think about the poor. We should not find expensive advanced solutions which they can't pay in China and India, for example, but make sure that we can help the development. In the European Union, we have money. We say in all directives, which are our energy laws, it should be cost effective and low carbon. It should also be resilient, but I think they have forgotten that. The EU has forgotten that resiliency is very important. Now they know. But also, some people forget cost effectiveness and only think about CO2. In this way, you can make some wrong decisions and save CO2 in a cost expensive way. In Denmark, the parliament have also the objective that it shall be cost effective and resilient, taking into account environmental costs. In our cost benefit analysis for the society, which we use in Denmark, when we take decisions within which energy solution to choose. We see what is best for the whole society, and pretending that Denmark is one profit center. And we put money on environmental harmful emissions and CO2. It's even in the first paragraph. Take into account CO2 and the cost effectiveness. That means CO2 in itself is not a criteria for any decision in energy policy in Denmark. What about the city? A city council should actually say the same. City council, we should pretend that we are the board of directors for the city, pretending that there's only one company, namely the city, put all stakeholders together, break down all barriers between buildings and sectors to see what is best for the whole city. This should be the objective. And this is what when you do analysis for a city, we make such an analysis for what is best for the city, and then later we divide on sectors to make sure that those who are going to invest, they can find it profitable and they can pay back and be cheaper for all residents. In the EU, we have some directives, strategic environment assessment, saying that ministries shall cooperate. Energy performance directive of buildings, saying that buildings should be cost-effective energy, low carbon, but take into account that you can use district heating and cooling. It says, but some people forget that. If there's no district heating and cooling, then two other directives actually state that cities should plan for district heating and district cooling to transfer renewable energy via district heating and cooling to the buildings. Because actually most sources for efficient production and for renewables can only be used in buildings if you transfer it through pipes from bigger plants. It's very little you can do it in buildings. In the cities, you can do it at the passive house. Out here, you can make some special things for that, but you can't do that for every building in a city. And the directive also states that power plants should be located near cities, so you can use the heat. And in Denmark, we got Electricity Supply Act in '76. And based on this act, Poul Nielsen in 1981 could approve Heat Plan Aarhus and the new power plant, first new power plant since '76, to be a CHP plant. It was not the power company who decided that, that was the minister. And since that, all new power capacity in Denmark has been combined heat and power placed the best way to use the heat. And the Heat Supply Act, also very important, that is the one with the first paragraph with the cost effectiveness taking into account CO2. And this act actually demand that municipalities should prepare heat plans, and so minister could approve that up till 1990. Since 1990, minister has only issued guidelines. The municipalities are the planning authority which approve projects, and but they don't prepare heat plans. They ask utilities to prepare investment projects, feasibility studies for improving the district heating, and then the city council assess them and approve them if they are good, delete them if they're not. And then this approval can be appealed to an appeal board, which will look and see if the district heating company has followed the guidelines from the ministry. This holistic approach, as we say, that we look at all sectors, find what is best for society, actually has opened for a lot of sector couplings. Combined heat and power, combining heat and electricity. There's a lot of, and now also combining heating with wastewater sources and industry. There's a lot of integration, which is very important to find the best solutions. The only problem we have now is the building code, because the building code in Denmark is actually manipulated by the building industry and actually is against the Heat Supply Act. It undermines the decisions taken according to the Heat Supply Act. I'll come back to that later. So let's take this for the last half an hour. I think I could use for taking the history of district heating in the green transition seen from my point of view. What is of interest? It started in 1903 in Frederiksberg, where there was a terrible problem with landfills in the city, so they decided to incinerate the waste and use it for generate steam to a hospital. Inspired by the US. At that time, US district heating was a hit in the US, many district heating companies, but since then it has gone down to almost nothing. In Denmark, it has expanded dramatically. In the period up to 1960, roughly, It was mainly developed in the big cities where you used the heat from the power plants. The city council owned the utility, which owned the power plant, which generate heat, electricity, and could use the surplus heat for district heating. It made sense. Fortunately, they decided to use hot water instead of steam, only steam in central part of Copenhagen. So this way it was prepared for the future. So what happens in 1960? In 1960, the happy 60s, as we say, welfare grew in Denmark. Everybody should have a bath, a toilet, and central heating. But how to heat the central heating system in a building? With a coal boiler, it was polluting, and an oil boiler was expensive. So actually, they found out even in small towns to go together, establish a cooperative, and to use heavy oil instead of light oil. To use the economy of scale by cooperating. And all of a sudden, we had many district heating companies all over Denmark. But the technology, the concrete duct systems, could be very manufactured, prepared very good, 100-year lifetime in the cities where it was big concrete duct systems with draining. But in the small towns, it was a bad quality. Pipes were leaking, and we had some very bad problems, like we saw in the Eastern European countries in 1990. But we had them in the 70s. So what happened? The most innovative technology development in Denmark, I think, which has had the most positive impact, is, you see this gentleman here? You know where he lived? Not far from here. He was a little blacksmith around the corner down in Løgstør, a small town nearby here. And the local district heating company thought, well, we have a problem. And he said, maybe we could make some pre-insulated pipes, plastic around the pipes with insulation. Let's try that. But it failed. It was not so good. So they said, they forgave him and said, okay, let's do it better. We forgive you, we will not bring you to court. Let's try once more. And they made it a little better, so it worked in Jutland here with sand. And let's go to Zealand with it, where we have clay. It failed because I've seen some pictures. It was terrible because they were not tight. They were corroded in 7 years. So, but they made it better and better. And in 1980, this technology was ready for the big boom. And today we have the world's largest manufacturer of pre-insulated pipes in Løgstør. And thanks to this technology, we have district heating systems with low heat loss and lifetime of 70 years or more, and spread all over the world, also for district cooling. And that means that the market share of district heating has been at least 2 or 3 times larger because of this technology compared to concrete ducts. Later came the wind turbines, developed also in this region actually, with the same principle. Let's try, the blacksmiths can put it together. It failed, break down, but let's do it better. And it fails also. Next time we do it even better, and then all of a sudden it works, and then many companies compete to find the best solution. The same history repeats it. Now we are waiting for the third innovative technology development in this region here. Maybe you have ideas here. To the next period, from 73 to 79. In 73, we got the first oil crisis. That was not so good. And Denmark was almost 100% dependent on imported oil, you know. And do you know what happened then? The Prime Minister, Anker Jørgensen, he said in a speech in Katamina, I think it was, we actually support the Jewish people in the war down there in the Middle East. And then OPEC said, no oil to Denmark. And also, by the way, also to the Netherlands. And then the parliament said, never again, we will never again be dependent on some kind of dictatorship which we don't rely on. So we were ready, prepared for the new crisis here where Russia now appears to be the crook. Then they considered what to do, and in 76 we got the first energy plan in Denmark, which said we need nuclear, we need a lot of combined heat and power, and maybe some renewables. Later, nuclear was cancelled, but based on this plan, we got the, let's say, the basis for the Heat Supply Act in Denmark and the Natural Gas Act. So in 79 we were ready. We were ready with a new gas infrastructure, decided not because it was cost effective, but because we needed one more energy source to replace oil and our own gas, Danish gas. And not least, district heating was then based on heat from power plants, and waste incinerators were considered as one of the main pillars in this transition. Here we see Vestforbrænding. They also went together, municipalities joined forces and established a big waste incinerator to generate heat to develop district heating in the neighborhood. Here we see from 1980 to 90, we see up here Heat Plan Aarhus. My first real project where now Heat Plan Aarhus has replaced the coal with biomass, and then now I'm in a transition to integrate more renewables with electric boilers and heat pumps. And down here you see the greater Copenhagen area where I've been working. We helped Poulsen to establish this, encourage all 20 municipalities to cooperate to establish utilities, and actually force the power company to say where the power plant should be. And without nuclear, there was even more need for district heating from the big power plants. But also in this period, 1980s, we also discovered that we could burn straw. Straw is a very difficult fuel, and there were a lot of experiments how to burn straw. They failed and tried again, failed and tried again. All of a sudden we had technology for burning straw. And we imported wood chip technology from Sweden. Very soon Danish boiler manufacturers actually managed to produce very efficient wood chip boilers. So what should I say then? Also, you know here, the wind energy developed in parallel. At that time there was not too much combination between district heating and wind because they had nothing to do with each other. But now we know they are very closely linked together. I'll come back to that. Because what happened then from 1990 to 2006, roughly, we can say that the sector consolidated. We had to pay back the gas project. The most important energy policy objective in this period was to save the gas project, to make sure that the gas project is paid back. So the politicians said to district heating companies, you are not allowed to use anything but gas unless you have cheap heat from the power plants. So district heating sector was put down as an underdog, so to say. But also the heat supply planning was then made more decentralized. Instead of a top-down, bottom-up planning, it was now only a bottom-up planning where utilities prepare project proposals on what to do, and city councils assess them and approve if they're good, and that can be appealed to the appeal board. Gas companies always complain, say, don't touch the gas. What should I say more? You can see new technology development. This is a big heat storage tank, pressurized, for example. So there was some technical development also, and gas fuel CHP plants developed. We have never seen a gas engine in Denmark, but those who work at the district heating companies, they have experience from the marine, from the ships, and such an engine, diesel engine you have in a ship, you could put it into a building and then you can generate electricity and surplus heat. So all of a sudden we had actually gas fuel CHP all over the country, maybe 100 places, decentralized production of electricity. Instead of building one big gas-fueled power plant which let out the surplus heat, we have many small ones which use the heat and which can regulate up and down. And this is now a real asset we can use later on. So in this period also we used fully the CSP potential. As I say, we minimized the heat losses from the power generation. And do you know, in our neighboring countries, what did they do? In Hamburg, Moorburg, they have a 2,000 megawatt coal-fueled power plant in the middle of Hamburg. Same size as all the Danish coal-fueled power plants together. How much of the heat from that plant do you think they have utilized in this period? Zero. Nothing. Let it out into the river. Instead, they have imported Russian gas to the gas engines, or to gas boilers, mainly gas boilers, yes. Yes, gas boilers. What happens in 2006? The Prime Minister, which was previously Mr. Anders Fogh Rasmussen, he said at a speech, we have a vision that Denmark shall be CO2 neutral and at least independent of fossil fuels in 2050. Wow, at that in 11 seconds, every energy planner knew, wow, what we should do, more or less, with known technology. We shall have we shall have much more district heating and use how we can use the renewable energy, and also how district heating can help to integrate wind energy. We knew that. But what happened? Everybody said, yes, we will do that, we can do that. All building owners said, we can generate our own energy in all the buildings. And even the Prime Minister said, now, soon all buildings can generate their own energy. I mean, it's like Donald Duck. I mean, you can make it, do it in a unique building, remote here, for example, but not in the city, not in normal buildings. It's impossible. Also, the power sector said, we can deliver electricity to everybody, but we're smart. We are very smart, because electricity is smart. But really, it was not smart. And the gas sector says, well, we can supply gas. So everybody forgot district heating, unless we were some people, me and Ramboll and Aalborg University, who actually, by the way, district heating, it has so many qualities. And only in 2010, I think the parliament actually understood that district heating would have a role. But it was difficult to hear us because there was so many shouting. All commercial interests shouted, and use my products, then you are smart. Use my data, then you are smart. Yes. So the district heating took action in many ways. I could say also here a lot of things we did, but there were also developing technologies. Large-scale solar heating was invented in this period here, with heat storage pits. And as regard the wind, now comes the wind, because the government realized that in this period here that wind shall be our major resource, because we have so much wind resource. But how to use this wind when it is fluctuating? It can, the most efficient way actually to integrate, to use it in combination with district heating, so make sure that as much electricity as possible can interrupt at any time as long as needed when the wind is not blowing or you have lack of power. And all district heating can actually use electricity replacing biomass and other sources in the long term, and all this electricity can be smart use of electricity, be interrupted at any time as long as needed, and thereby be a big value for the power grid company, so that you can use the grid to transfer wind energy to the district heating companies, and then as soon as you have problems in the network or you have only expensive electricity, then they just disconnect, disrupt, and use other sources, heat storage tanks. Also, district cooling was in progress in this period here. Also learned from Sweden, which started in 1990. We started in the year 2010 with district cooling. So what will happen in the future up to 2030? Because in 2022, the government had said until 2022, the policy was gas is cheap. Use it as long as it is cheap, and we have it. In 22, we ran short of Danish gas, and price went up. And then the government says, oh, by the way, you should have replaced all these gas boilers with district heating. Can you do it now, at least very soon? But the contractors and consultants, everybody who had actually found other work to do, so we have not too many resources, and this stop-go policy is a scandal. We should never look backwards and say it was a stupid idea, because it has happened, but now we are in a problem. Everybody wants district heating, but there's not enough resources to do it all at one time. So we have to find solutions on how to do it. And also the wood pellets, the big power plants which use coal, instead of closing the plant has been renovated, lifetime prolonged, and we shifted to wood pellets as a temporary solution. In 2030, roughly, several of these very, very old power plants using wood pellets, they are worn out and will be closed, and then we need new capacity to the district heating, and that will be heat pumps and large heat pumps and electric boilers. And large heat pumps can use surplus heat sources from many sources, from waste water, from data centers and from industries, and if no other solutions, they can find somewhere to put an air, capture heat from the air. So with a district heating system, you can use wind and solar in a cost-effective way by taking into account the price fluctuations. Also the gas engines we have installed in the 90s can now be used to generate power to the grid when wind is not blowing. And this year, not so long time ago, the Climate Commission finally found out what we have known for 10 years, namely that we can easily integrate wind energy if our electricity consumption is flexible. Yeah. Because until now, the power company has said, oh, we just need one more power cable to the neighboring countries. They will probably help us. But they looked at the weather forecast and see that when you have a critical weather situation, it's the same weather in all Northern Europe. Wind is not blowing all over the place because we have high pressure, stabilized, very cold. So we will not have help from other countries. We need to help ourselves. We need to be able to shift from don't use electricity when prices are very high, but instead generate electricity with the gas engine and gas combined cycle plants, which can use biogas and in the long term also renewable gas. Because the new thing which will come develop now up till 2030, that is two technologies combining. That is, one is the carbon capture. To capture CO2 from the chimney, from plants which run continuously, waste incinerators, and biomass fueled plants which are baseload, which generate heat to the industry. Here you can take the CO2 very efficiently, and you can put it into the ground, so you will have negative CO2 emission. But having this market for CO2 where you can deposit it, you could also use it for greenhouses and use it to capture the hydrogen. Because the other technology which we have in development now is the electrolyzers. They call it power to X to be smart, but it is simple electrolyzers. You generate hydrogen with electricity. But this hydrogen is very difficult to handle. It is not a good idea to have hydrogen to all buildings, but a hydrogen can be transmitted to Germany in a big pipe, and thereby replacing a high voltage power grid, above ground. But you can also combine the hydrogen with CO2 and produce, for example, some, let's call them hydrocarbons. It could be kerosene, which can be used for the aircrafts. It can be light oil. And this kerosene, it can also be methanol, but methanol is flammable like gasoline, so it is not so good to have in a tank. It's better to have kerosene. And you can have this kerosene stored in tanks for backup boilers for district heating, which can go in and to replace biogas if biogas is too expensive, and then generate heat in these short periods where we have to interrupt the heat pump because power prices are high. So in this way, the power can generate hydrogen, which can be stored and be backup fuel for the wind when it's not blowing. This is kind of a smart seasonal battery.
There are two big energy losses in the process.
You're right, there are energy losses, but in this process, when we capture hydrogen and when we have electrolyzers, there are losses, which is heat losses, and all these heat losses can be used by district heating. If you have a district heating network, you can use all these losses. That's one of the points, combination with district heating. So many integrated couplings, but you cannot see, in countries without district heating, you cannot see all these smart things. So district heating is actually a very smart thing, a very smart technology to have in the green transition. also in the future. There's a little about history and perspectives. Here comes a little about holistic system and sector couplings. Really many sector couplings. Here you have the integrated energy system where you see many people say energy gases and heat. A little about Danish combined heat and power and waste. We really have lack waste incinerators in Europe. We have enough in Denmark, but could have more, and actually also timber, the role of wood. Biomass, produce, let the forest. We have natural forest, of course. We must have forest for nature, but also forests which can generate wood, which can be used in buildings, and waste wood can be used for heating and power, generating power, and also for capturing CO2. And this cross-laminated timber is like this one here. This cross-laminated timber here can also be in big walls, which can replace concrete. Just an example that some people say that the cement factory in Denmark is the biggest climate polluter, but it's the world's most efficient power cement plant, because the heat is used, so it's an asset in climate conditions. This plant is an asset. Because the problem is that somebody used cement. Yes, that's the problem, not the plant which generates cement. That was another story about some of these confusions we have. And then combined district heating and cooling. I have some very good cases. The world's smartest district cooling system, I can tell you about. I have been involved in that. And also the role of the gas sector. You see the gas consumption will decrease and the biogas production will go up. So in 2030, all the gas, as you say, will be biogas, and we can add up with renewable gas. And urban planning, sustainable urban development, Greater Copenhagen, a little story about that, and also about the energy system as an asset for the city, how the city council should think. And here we have some good and bad cases in Denmark. The green ones are very good, the red ones is not so bad. That is the main remaining biggest problem in Denmark is that the building sector is isolated by itself and tries to undermine the rest. So the lesson to other countries is to make sure that ministries cooperate. When Mr. Poulsen was our first Minister of Energy, we had a group of ministries, so the Prime Minister called all ministries and said, all ministries, you have to make sure that we can implement the gas project and the district heating development. If there are any problem, cancel it, delete it. We must promote all these, and all ministries cooperated. Today, ministries fight each other. They fight each other. Ministry of Taxation have their own policy, energy policy. Ministry of Building have their own energy policy against the others to promote to their own interest. So the lesson to other countries is that you should make sure that ministries cooperate, because ministries wants to have their powerful, it's a problem. Then comes some showcases from EU reports, 8 good projects, case studies in Europe, 2 from Denmark. The problem is that they can only have 2 from one country, so we could have many more. Yeah. Thank you very much. You can study these. Yeah! Very big applause from me.
Okay.
Yeah.
You see, Arne will be together with us until 1:30. So there will be time to talk to Arne. Is that okay, Arne?
Yeah.
That we say so. Yeah.
Ringe befolkning. Og hvad hjælper det så, at man kan få gratis fjernvarme måske, hvis ikke der bor ret mange mennesker, og de anlæg der? Hvad kan man bruge fjernvarme til?
So the question was, when we are living, set up power to X installation, also in places where we are few people, how can we use the the heat?
Yeah. What we need in Denmark is a national plan for where to have energy consuming, really energy consuming industries like data centers and electrolysis plants. We need to know where is the best place, taking into account the distance from the wind turbines and the possibilities to use the heat. All these things put together. We don't have such a plan now. It's who comes first to propose? And we should be careful that it's not the owner of the data center or the owner of the company who wants to make some first power to X that they decide. It should be decided based on a national planning where you take into account the use of heat. But I'm sure that in the long term there will be more heat from the power to X than we can use in district heating. So we could accept that some of them are placed where we can only use a little of it. You're completely right. It is a problem now. It's like an anarchistic, chaotic situation. The first big data center came near Viborg, but far away from Viborg, in the middle of nowhere, because we wanted to attract data centers. So they decided they wanted to be here. Instead, we should say to data centers, you can be here or here or here. We should have a choice. Yeah.
Just out of curiosity, you said that power to X was, simply speaking, electrolysis. But don't you think that the X could be other things? It is true if it is hydrogen, but don't you think that the X could be other things than hydrogen? Because yesterday when Lise Nielsen was speaking, she said the X could be a various kind of things. You know, methanol and maybe...
Yeah, but just a moment, because first of all, power to X, in my mind, power to X could also be an electric boiler. An electric boiler to district heating would use electricity which else would be wasted if wind turbines stop. It is also an X. But the basic X is to generate hydrogen. And from hydrogen, you generate methanol. You take CO2 and put together with hydrogen, then you have methanol in a chemical process. And you could put one more CO2 on, then you have kerosene. So, and you could also make ammonia, which can be used in ships. And but the basic thing is electrolysis, which generates high temperature heat loss, and then combined with other. Yeah.
So Lisa has the last question because Katherine Dykes should be on.
I mentioned district cooling. Do you have any idea of the potential in Europe or globally? Because cooling is becoming a bigger demand than heating in some places.
Yes, globally, I think district cooling is even as important as district heating. In some countries, district cooling is the main issue. Heating is not a problem, only maybe locally for hot tap water and for shower. In the Mediterranean area, like for example in Spain, a typical new urban development will have both district heating and district cooling. And also at Stanford University, both district heating and cooling to the whole campus. Depends on the climate. In our situation here in Denmark, it should be district heating to all buildings except some remote in the outskirts of the city, and district cooling only in business area, city center and business area, which of course is closed to a public transport. You have a metro station, of course you have all buildings around that should be, according to good urban planning, be shopping centers or office buildings where you work, and they have all active cooling demand, actually according to the building code, so they need active cooling, and therefore you have a cluster where you could have district cooling. But in India and in Sri Lanka, the big issue is how to control the cooling demand, because the uncontrolled demand from individual chillers actually stress the power system. You have blackouts because of this cooling peak. So you need solar PV combined with district cooling in order to solve that problem.
Thank you, Anders
Dyrelund.
And we will continue for the Zoom.
The camera is here with the microphone, so let's here.
So I should talk to these. So welcome. So we welcome you now. This.
Great. Thank you, and so sorry I was here in person today. I'm running a 2-week training program, and one is wind and solar and
introduction to myself, I'm Katherine Dykes, and I'm currently a senior researcher at the Technical University of Denmark. I work in the DTU Wind and Energy Systems Department, where we're working on, kind of supporting the development and research in wind energy physics, technology development, social and environmental aspects of wind and economics and all of these things, and then also broader power system work, looking at energy systems with lots and lots of renewables and how do we operate them. What I was asked to talk a little bit about today by Jane is actually going back to some of my Ph.D. work, which was now many years ago, where I actually spent time looking at the development of wind energy and spent time at the Folkecenter with Jane and Frede and others, understanding the history and the development of technology in Denmark and the US and beyond. So I'm going to talk a little bit about that today. I guess I have a half hour. Do we still have a half hour, Jane, or should I?
Yes, you have the half hour.
Okay, and I'll try to keep it at least a little less than that, so if there's questions or discussions. And so, the context for the story, of course, is the exponential growth in wind energy that we've seen over the last few decades. This only goes through 2015, but if we look at the last few years up to now, the story continues, just exponential growth, which is a great story, coming from where we were in the 1970s, with little to no wind energy in our electric systems. So it's a big success story, but then it's not one, it looks very nice and smooth here, but it's not one that actually is so smooth if you start to dig into the details. And so what this is a picture of is the development in wind energy over time in different countries, some of the leading countries that have wind energy development. Of course, you see the US there, and Denmark, and China, where there's lots and lots of wind, but in many places around the world, the development of wind energy has been a stop and start. It picked up in certain places and then stopped in others, and it's quite tumultuous if you look at an individual country scale. Even in Denmark, there's been periods of growth, and then there's a period in the 80s where there was a significant bankruptcy and whatnot. So, this kind of, beautiful story we have at global scale, it gets more complicated when we start looking individually. And that connects to innovation traditions. So there's different innovation traditions, and there's many scholars here in Denmark and elsewhere that have been studying these innovation traditions, and so I'm just going to give a little snapshot of a part of the story today. This sort of wind energy development at national levels is tied to innovation programs at national levels. And in my own work, I looked a lot at both Denmark and the US, understanding those traditions and how things develop. So of course, what I'm going to be talking about today is the Danish story and perspectives, and of course the role that the Folkecenter in Nive played in that history. Kind of moving back up again to the global level, if we look from a technological perspective, there's again this sort of smoothness, where there was a relatively early sort of consolidation through platform standard for the technology, and then continuous innovation from there. And again, with Denmark as the epicenter, the global epicenter for this development, and that's what brought me to Denmark. That's what brought many of my colleagues to Denmark. Is this focus and leadership that Denmark has in wind energy technology and development. So that's a bit of the context, and so now I'm going to talk a little bit about what I call the different epochs in the history of wind energy for electricity generation. So of course, windmill technology has existed for since around 400 AD or even earlier, depending on which types of technology you want to look at. For electricity, we're really talking about, of course, mainly the 20th century, a little bit in the 19th century, and of course into the 21st century today. So I'll talk a little bit about early wind electricity generation, because it's important as part of the history of particularly the Danish wind energy story. And some of the first developments of large machines, and then how that led us to the modern wind turbines today, and the Danish concept and modern wind turbine technology. So, looking a little bit back at a historical perspective, the kind of takeoff of development of electrical systems happened, in the aftermath of actually Hans Christian Ørsted discovering electromagnetism, leading, eventually to the development of electric generators, lighting systems, and the like. And so, of course, there's a lot of activity in invention in electric machines in the 19th century. And, it's perhaps not surprising that, as people were playing with, electric machines, that they already started thinking about, how could we actually use, wind or other forces of movement, water, etc., to actually spin these generators and create electricity. And so the first, at least that I know of, patent or mention, in sort of in kind of the industrial space of a machine for harnessing the wind and producing electricity was from a Belgian inventor, Millet, in 1841, where he filed a patent about using a wind or a water motor to generate electricity. There's not evidence of the actual machine existing as far as I know, but the concept was there, and the concept, kind of embodied some of the characteristics that we look for. So this idea of a machine at low cost, being able to produce continuous movement, uniform movement, so consistent movement, and that's something that we think a lot about in terms of the design of wind, is how to harness the variable, wind energy and turn it into a consistent electricity source. Having little repairs and being a very safe system, how we can use wind to create such electricity generation. So, that was as early as 1841, but it wasn't until the late 1800s that we first saw actual wind electric generation machines. So there were a couple of early examples. There was James Blythe in the UK. A relatively famous one in the US was Charles Rush, who built a 12 kilowatt machine and had it operating as early as 1888, powering his laboratory facilities in Cleveland, Ohio area. And so there were several examples of people, essentially taking existing concepts for windmills and then retrofitting them for electricity generation. And I'm sure many of you probably know that one of the most successful inventors in that time who developed a wind electricity generation system was actually the Danish teacher and scientist Poulsen. And he was, of course, a key figure, is a key figure in the history of wind energy, both technology and modern science. He did a lot of experimentation and research, for example, on things like the aerodynamics in wind that are relevant and helped us understand better the physics of wind energy. But he, was the first inventor to arguably develop a wind electricity generation system that was commercially successful. So he had students, these boys of Ascot, who studied under him, learned how to design and build these windmills, and actually built many of these windmills around Denmark and northern Germany in sort of the pre-World War I through World War I period. And of course, World War I was a period of where energy was scarce and costly. And so, we think about the 1970s, of course, being the massive oil crisis that drove us to, kind of the modern wave of renewable energy development. But there were several, energy crises that happened at different times since the mid-1800s that actually spurred thinking about alternative sources of electricity. And so World War I was one of these epics which, kind of about trying to use more wind for electricity production. And so there were a lot of these generators developed and deployed for providing electricity, particularly in rural communities. Of course, the grid systems were already getting built out at the end of the 1800s and in the early 1900s. But in many areas where you didn't have a grid system, of course, wind was a great way to provide electricity for rural communities. As more diesel gen became available at an economic way, and as the grid got built out from the 1920s and onwards, we saw a decline in the development and use of these wind electric generators in Germany and Denmark. However, that wasn't the case in the US. The US actually, well, it took a very, very long time to fully electrify countrywide. So, outside of the major urban centers in the US, there was a small amount of actually grid access to the rural population. So just 5% in a period where, a lot of Europe was being electrified, only 5% of the US rural population had access to grid service for electricity. It was seen as a luxury. And of course, that laid an opportunity space for other technologies to come in, because electricity was something desirable that, of course, the rural communities wanted to have. This led to what we call the wind charger era. So it's kind of like thinking about before the mass production systems, but applied to wind energy. So small scale propeller-based technology. So this is post-World War I, where aviation technology is really taking off. Aviation science, you have people in Germany like Albert Betz who are doing research on kind of modern aerodynamic type of machines and wind energy physics. And that gets built into this new generation of wind chargers that are essentially a solution for electric power in rural areas, and particularly in the US, where you didn't have a lot of grid opportunity to connect to the grid. Over 100,000 of these machines, so a very large number were actually mass produced. And there was actually kind of gimmicks out there where there would be advertisements by Zenith Radio. Zenith acquired the wind charger company. And they would say, buy a radio and get a wind charger. So they would actually sell the radios and the wind chargers together as a package deal, as a way to get radio, which was kind of that was one of the most desirable use cases for electricity in rural America, to be able to be connected by radio to the world. And so many of these wind chargers were got out. So going from the core area, where still kind of sail windmill technologies, but machines that were built to last long, produce electricity reliably for electricity generation from wind, to now we have propellers type of technology starting to get into the mix. And it was at this time then, this is from like roughly the 1930s through the 1960s that we're looking at, that we started to see the first large-scale wind turbines. In the US, we had Palmer Putnam. There was examples in the Crimea region of Russia, in France, in Germany. There were several machines that were developed some by industry, some by research communities, that were on the order of 100 kilowatts or more. The sort of first generation of large-scale wind turbines. And those turbines were using this sort of modern aviation technology. So building on the learnings from the aviation sector in terms of the aerodynamics and things around lift and airflow technology, and then bringing that into machines designed to produce electricity. Some of the most noteworthy machines to be developed were the Civ turbines that were developed here in Denmark under the leadership of Johannes Juhl, who was, probably many of you already know, but he was one of the students of Paul IV. So there's this sort of direct line in the heritage of the technology in Denmark from Johannes Joule, and then, as we'll see, up to modern technology today. So, again, World War II, another era of energy shortages, spurring again, as I mentioned, in the US, in Russia, France, Germany, other places, significant interest in wind turbine technology for electricity generation, and here in Denmark as well. So Johannes Joule, in collaboration with SEAS, developed a series of 3 turbines, different technologies in each case. You can see the 3. The first on the left was a 2-bladed machine, and so that was an interesting concept, and there's a whole history around 2 versus 3 blades and what makes sense. We'll leave that to another time. But then 2 kind of machines that actually work in many ways similar to what we see in modern turbines today are 3-bladed upwind machines, so the Volvo and the Getzer mill. Getzer mill actually ran for quite a long period of time, over a decade, and was actually in the 1970s, late 1970s, was refurbished and ran again to collect experimental data to understand this machine better, and so this machine plays a pivotal role, as does Johannes Joule, in our kind of modern history of wind technology. And of course, if you haven't already, I suggest sometime visiting the Energy Museum, where they actually have the Getzer mill there. Now that has been decommissioned permanently, as you can see on the ground there, but you can go and visit and see the machine up close and personal. But there was a lot of thinking that went into this machine, again, around the aerodynamic design of the blade, using techniques that had been developed by the Germans in the first half of the 20th century, and really thinking about the design of the machine. So it was an interesting design because it actually had a relatively low design tip speed ratio, or maximum tip speed, of 38 meters per second. That's much, much lower than modern machines. And there was some thinking around that that Johannes Joule had put into it. But that sort of design thinking, again, comes back and influences the thinking that goes into the design of wind machines in the late 1970s, early 1980s. So sorry for my teams popping up there. I should have shut it down before we started. On to modern wind turbine technology. So that kind of takes us through the prehistory, and of course, the oil crisis was the big thing that spurred the modern movement. So, we had hundreds of thousands of these wind chargers for DC generation that had been built and were heavily developed all around the US, but also globally as well, throughout Europe and other places as well. But as the grid system really kind of develops, and especially in the US, rural areas were electrified in the late 1960s through the 70s, these machines were decommissioned and no longer used. Enter the oil crisis, and now we have another reason to look again at wind technology. Sorry about this. And many of you in the room may have been involved with some of the activities. I know many people at NIVE, predecessor to the Folkecenter, were involved in kind of thinking about, okay, for Denmark we don't want nuclear power, so what can we do instead in response to this oil crisis? And so there's renewable energy, so wind and solar, the opportunities to address and achieve a secure energy supply. So this is where NIVE comes into the story, and Frede, I had the pleasure to interview him several times when I was working on my Ph.D. many years ago, and talk to him at length about the activities of the different organizations in Western Denmark, the blacksmiths and small companies that all came together to develop this technology. And I spent time, of course, going and visiting the spin mill and talking to the people involved with its development, understanding how all of these people came together to think about the development. But there were a few key design principles fed into the designs that really kind of affected, you know, the success of the technology, and it's important to highlight. So the one thing was the tip speed. Was 38 meters per second, which is actually, like we said, quite low. And that affected the design of the machines, and especially the blades. So here you can see the ochre 5-meter blades. With the tip brake technology being another thing that was influenced by the Gedser turbine. So many of these design features that were part of the Gedser turbine and Johannes Juhl's effort came into the modern machines. So we had a whole community of people working together, and this led to, you know, kind of a common supply chain upon which the modern Danish wind industry was born. So this is a figure that put together with Katherine and others when we did the book on wind power for the world many years ago now. Just showing that there's this, you know, kind of community and common foundation for the technology, which is, you know, helping foster the global success that Denmark still has today in the wind sector. So the principles of the Danish concept, this is something that many scholars have explored, but it ties into, you know, some design principles that carried over for the Gedser turbine. And this was, you know, we can kind of sum up in, you know, design principles of conservatism. So there was a lot of conservatism that went into the Gedser machine design in terms of, you know, the loading and how the components were dimensioned. And that actually influenced and was carried directly into the modern wind machines as well. And so the modern wind machines, especially the first generation of 22 kilowatt, 55 kilowatt machines that were heavily, that were deployed heavily throughout Denmark and also the US, particularly in the early 1980s. They were designed with a large amount of conservatism. What we would call over-dimensioned components, but very reliable machines that did not break down, particularly when they were deployed moving from western Denmark, where you have quite strong and consistent winds, but the turbulence is relatively moderate. Moving to the US, where we had a massive development of wind capacity in California in the early 1980s, in highly turbulent conditions that broke down many good designs, but the Danish designs with the conservatism that was built in and goes back to that Gedser heritage. The machines were able to withstand the harsh conditions where they were deployed in the hills of California. And I've visited out there many times, and many of those machines operated for 20 to 30 years or more. You know, I was there in the late 2000s visiting San Borgonio Pass, Altamont, some of these places where these 55 kilowatt machines were still operating at that time, having been deployed in the early 1980s. So great success story overall, of course. And it goes back to this shared knowledge and learning. You know, there was design practices that were embodied in shared written materials and shared amongst the builders of wind turbines in Western Denmark. And this really helps for the development of the industry. So I mentioned the wind rush already. So you know, this era in U.S. history, there was just a confluence of regulatory factors that came together, both at a national and then at a state level in California, that created a wind rush. And you know, thousands of machines from different manufacturers were deployed all throughout California in the early 1980s, and it was really where the technology was really tested under harsh conditions, and the Danish technology proved to be very successful, and that continued to the current day. So here you can see, you know, images of some of the areas. So you have Altamont on the far left, San Borgonio, where you just have really pretty extreme wind conditions. You know, if you think about how we design wind turbines today for certain standards of, you know, kind of harsh winds and gusts and turbulence. So these machines were put through the paces and did really well. So that's the history of, you know, where we've come from, and you know, up to now. And so, you know, it's this this trajectory of scientific knowledge and engineering practice that started with Paul IV in the late 1800s, early 1900s, to John Sewell in the mid-century, to the modern wind pioneers like Frede and others, the blacksmith, the engineers that started Vestas and Bonus and Magmicon and all these companies back in the day, and built on those learnings to create strong, robust machines that could withstand really harsh conditions deployed pretty much anywhere in the world. And that's allowed us to continue to scale up the technology. We're nearly at a terawatt of wind capacities installed worldwide, and it's amazing to think, you know, that we've come this far, you know, in just 4 decades, really. And that's what we're celebrating here today, you know, the 40th anniversary of Nive, and 40 years of consistent, you know, wind innovation in the modern wind area here in Denmark. So, I think with that, I'll just sum up. So the history is way more complex than, of course, I've described today. I just chose one snapshot focusing on a few elements of the history here in Denmark, and where Nive played a critical role, along with all the engineers and blacksmiths working together to develop modern wind technology. There's a lot of different factors that contributed to wind energy success. And as a final note, I think the important thing to also note is that the story is not complete. We've come so far, you know, having nearly a terawatt of wind energy installed locally today, and that's fantastic. But if we're really going to solve climate change, we're talking about going from, you know, about a terawatt now to 10 times that in the next several decades in order to really combat climate change on the scale that we want to. So that's what folks here at DTU, like myself and others, are working on. Is we've come so far with wind energy already, but we want to unlock the full potential of wind to really help it become a foundational source of energy for our future clean and climate neutral energy systems. So thank you.
Thank you. Thank you for your presentation. I'll just say to you that you and your students are always welcome to come at Folkecenter and see our exhibition and all the old things. So thank you for your speech. There are some questions, Katherine? Yes?
Yeah,
Paul?
Yeah. To give you the context of my question.
Paul, you have to come here and speak such. This is the microphone there.
Yeah, the end of your presentation in the US and Denmark reminded me of a movie you probably have also seen, Hermann Scherpiet, The Fourth Revolution. And the background in California he gave, he commented as a graveyard of the bygone days. And do you have any takeaways of how we can prevent such a complete slump as it was in the US? I think 90 was when Bush Jr. was elected. Is that related, and what would be the takeaways? How to prevent a complete breakdown of an industry?
Yeah, that is a great question, right? How do we stop history from repeating itself? Because so it was Reagan who really sort of walked back from some of the policies. And so it was around 1984 that the market in the US collapsed. And it really not only impacted the sector in the US, but Denmark as well. And then we had a few periods in 2000 where policy support for wind, like every other year, was removed. And so the industry was just, you know, kind of going through this roller coaster. So that goes back to that story where even though if you look at the national stories, like there's been you know, a lot of inconsistency. I mean, Germany stopped and started, Spain came in at some point, and so, you know, the individual stories are quite tumultuous, but the kind of like the nice story at the end was that at any given time, except with a few exceptions, there has been a good market. somewhere in the world for wind, which has helped the industry to continue to develop smoothly, relatively smoothly over time. And right now what we're seeing is big markets pick up in new regions of the world. So for offshore wind, right, we're now very successful in Northern Europe with offshore wind. And we're seeing maybe a bit of a saturation of offshore wind, although there's big plans for big development still of offshore wind in Europe. But we're starting to see those markets really pick up in other places. So, I don't think there's anything we can do to really ensure that politicians, don't, stop policy supports or what they need to do to continue to support, wind and renewable development. But I think the indications are that globally what we're seeing is really strong demand for wind that's going to continue for at least the coming decade or plus, cross fingers that I think, with climate change now being something that, governments around the world are very much taking seriously in terms of their energy policy. I think the landscape for wind energy development is pretty stable right now, and we're more worried about, can our supply chain actually keep up with the demand that's coming? How do we supply this many turbines and make sure that we still, kind of have the level of quality and reliability and safety built into all the machines that we're deploying around the world?
So we will thank Katherine Dykes. So thank you. So we continue our program, and I will welcome Mr. Poulsen to be on this here. Please come. So then we take away the Zoom here, and now you are here.
Having me here, I'm pleased to be here. Me and the Folkecenter and Jaeger has been working together for almost 15 years now, and we have achieved some great goals together, I think.
Sure.
Yeah. She's ended up with saying we have gone a long way, but we still have a long way to go. For me, it's about the direction we have to go. And that's what my speech is all about. Since the first human on Earth, we have used the ocean as a dumping ground. It has become especially worse since the industrialization. Chemical, toxic, plastic, and much more. We have learned nothing. We want to continue. Now they want to cover our backyard with wind turbine parks without knowing the environmental impacts. This is happening with a new government led by the Minister of Energy, Lars Aagaard, former director in the energy sector. Of course, he will favor his old friend in the industry, I believe. And remember, we don't have corruption in Denmark. Wind turbine parks in Denmark is meant to supply the consumption of 17 million households in a country with 5.6 million inhabitants. Simply does not add up.
But is it really the right way to go? No, I don't think so. Why it would be more advantageable to place large industrial chemical plants for power-to-X production in various forms on an artificial island in the middle of the North Sea. We need answers to the entire question of ownership, rights and obligations for the investors involved in the wind projects. We must take energy security very seriously. And who should own the operate the energy system that continue Denmark's infrastructure? Certainly, we need to become independent from Putin, mobile phones, and gas and oil, as well as the oil from the Middle East. But to go from one dependency to another, that's simply stupid in my opinion. Becoming dependent on Vattenfall, Goldman Sachs and other large investment companies makes no sense. We should aim for the self-sufficiency as much as possible. That could be achieved by installing solar panels on the many houses as possible. Allow farmers to profit from placing solar panels on the waste roof spaces they have, on industrial buildings, on public buildings, schools, kindergarten, nursing homes, town halls, and so on. Household wind turbine feasible, multiple turbines in the same area where it makes sense. That would benefit rural development, whereas offshore wind turbines will not contribute to it. Local banks, they can finance it, and local craftsmen would be installing it. That makes sense. Large wind turbine parks will be outsourced to consortiums that hire cheap foreign labor. That makes no sense. Locally, biogas plants should be developed to support the local energy supply, which is already happening, including here in Thy. In this way, everything is connected. Independency, local ownership, it makes sense. Get moving, Parliament. Instead of this insane wind turbine parks in our backyard. The same goes for the hectare-sized solar parks being built and planned on our agricultural land. Cultivate it instead or plant some forest. That makes much more sense. Thank you for listening to me. Hvis der er nogen, der har spørgsmål, så tager jeg gerne dem.
If there was questions, if Poulsen are very welcome.
Who will be the first? The second? That's okay.
Thank you so much.
Thank you. Yeah.
How will you make sure that the industries they are supported?
What do you mean?
I mean, you're talking about these local. We need to have all these local setups.
Yeah.
We have still a lot of heavy industries. We need a lot of energy somehow. How will you make sure that?
Yeah, but every household, they can have their own solar panel or wind turbine in the backyard and can be self-supported by energy, and that makes you independent on big companies who plant these big wind turbine parks in the North Sea, big cables through our land and so on. So it's more local. I think that's the most important thing. When all that has happened, you have to have some wind turbine parks to support the last few percentages. Yeah,
So
you
we
s-
need some large scale.
yeah, but not 17 million household. Don't build any island in the North Sea putting wind turbines for 17 million households when we have maybe 1 or 2 million households in Denmark. I know it's to support other countries in Europe as well, but they also have to find their own way.
So Paul,
Yeah.
we will not take any questions more because Morten Victor Petersen will also talk about the decentralized model, and then maybe there will be more questions. So thank you for
He has before taken some of my speech, so I can take some of his.
Please, Morten.
Det er godt.
So I will welcome Morten Victor Petersen to make a speech for us. Please, Morten.
Thank you very much, and thank you for inviting me. I'm here on behalf of the Federation of Small and Medium-Sized Wind Turbines. And it's a great pleasure for me to be here today and be present at this 40th anniversary here at the Folkecenter and to congratulate. The Industry Association was originally launched here, if you can use such a word, and I say without hesitation that it has not been for Preben Maegaard and Jane Kruse's great commitment to this time, at the time there would not have been so many household wind turbines around the country and also still are coming news in the world. The test center for small wind turbines, which we have here today at Folkecenter, was put in the pipeline already more than 13 years ago, well supported by our local politician, Poulsen, who had the pleasure of being here before me, and who has been invaluable and helpful for this test center. Thank you, Ib. And for the Folkecenter. And as I understand it, it was a long and tough fight to get it through. Thanks for your help. It cannot be valued enough what Folkecenter has helped other members, our members, during the past 13 years, and we look forward to a good cooperation in the future.
Thank you.
Tony Brink and Anker Mardal have worked tirelessly to get the test center up and running on a daily basis, and it must be said that they have succeeded very well. Together we have held many international conferences with many participants, participated in trade fairs in Husum, Germany and other places, events we all in the industry and hopefully also Folkecenter has benefited from. I would like to greet many times from our common friends in EREF, the European Renewable Energy Federation,
they take care of decentralized energy. They are unfortunately not didn't have the opportunity to be here today. But they also thanks for an exemplary cooperation. Preben Jaeger was one of the founders almost 30 years ago of EREF, and the great work for decentralized renewable energy is also carried out from there, from on here. Not only EREF, but the whole transition to renewable energy in Germany has actually, in my point of view, its origin here at Folkecenter. The German politician Hermann Jaeger, who laid the foundation for the energy turn, had a close relationship with and was inspired by Folkecenter and Preben Jaeger. I don't think Folkecenter has received enough praise for this. The World Wind Energy Association, a global organization, is another example originating from here, and Eurosolar can be mentioned as a third one. Folkecenter has been almost all over the fields from its inception. This is impressive. Likewise, the Danish wind turbine industry cannot thank Folkecenter enough for the great work that has been done. Just look at what Vestas and others has become and how the whole commercial life around it has developed. Solar cells, wave energy, biogas, energy houses. Yes, there's almost no end to the entrepreneurship that has sprung out from here, benefited from Folkecenter, and still does. The large global network, among others, these things carried by the trainees has helped to spread the knowledge of Folkecenter across the globe. And I would like to congratulate Folkecenter once again. There is a lot of very, very good speeches here about the very technical things. I'm just happy to be here today and give the best congratulations and look forward to another 40 years. Thank you.
Thank you so much. All the jobs that have to be done. So, Paul, do you have a question now? No, it's okay.
Would have been an answer to the person asking, and I can do that bilaterally.
Yeah, that's good then. Thank you so much, Morten, for the calculation, and you take in all the international association that has been created from these buildings here. That's true, yeah. It's quite interesting. It is mentioned in our book, so you will see it on print also. Then we will invite the next speakers, that is Frede.
lot for the invitation. And at the university, we've had a lot of collaboration with Folkecenter, and we've had many really good students coming here and finalizing their study at Aalborg University and coming back here also.
Yeah.
So it has been very important collaboration.
Yeah. Thank you for that.
And I think that Folkecenter is a unit in Denmark who has the most international connections. I think it is. It's not a university on this kind of energy policy you have here. And I'll say a little bit about, and I have a very short time, about how the North Pool market works. And I don't know, I think most of you don't know it, in fact. So if you have, you remember last year there was really expensive energy in August. I think it was around €1 per kilowatt hour in August. And the average price otherwise is around, was 3 euro cents. So the price was extremely high. But we also have a lot of moments or hours where the price is extremely low. That's because of the construction of the North Pool market. The North Pool market it's a very, in a way rather simple to explain, but I still don't think I can explain it. It should be simple, because you have, if you have 10 producing unit power plants or wind turbines, and you then the last one of these 10 is a natural gas-based electricity producer, and then it's the last one who is the most expensive, who sets the price on the market, and that's the price for you're bidding today. For instance, for between 1 o'clock and 2 o'clock tomorrow afternoon, and then 10 are bidding, and the most expensive one is setting the price. So in many hours, last year and also now, you have a very high price because the one setting the price is natural gas-based units. Or it could be also coal-based units, which are also very expensive because of the carbon dioxide tax on coal-based electricity. And that's what it's about today. It's about taking a historical view on the period from 2021 to 2030. That's a strange way of looking at history, but that's what's going on. It's a little bit linked to Poulsen's, what he was talking about. And the problem, I called it, and I changed it because it was too dramatic. The first thing I wrote how Nord Pool market kills wind power. That was when I changed it to this more diplomatic one. The problem at Nord Pool is that it's based on the high short-term marginal cost. That's on a wind turbine, the marginal cost is very low because you don't pay anything for the wind. So if the wind power is setting the price on Nord Pool market, electricity will be very cheap. So if there's a lot of wind power, you will have very low prices. And we are going into a period with a lot of wind power. In fact, I don't think that the market really can handle this. It can be, the price will be very high and very low, and sometimes a little bit in the middle, but at the same time as we have this market mechanism, we have a development where wind power should be more and more be doubled. As Poulsen said, it should go double within the next 7-8 years, extra 9 gigawatt offshore. It means that we really will have many hours where wind power is setting the price because we have enough wind power. If they don't build a lot of consumption units, if they build a lot of power to X, this can be reversed maybe. So, but I think, and that's what's written here, that incentives to invest in wind and solar power may disappear, because you could say wind power and solar power commits suicide. Because as soon as there's really many hours with wind power, the price with this type of market will go down to zero, close to zero. But we also have to pay for backup plants in periods with very little wind, so then the price can be very high for some hours. So there will be increased fluctuations. We will have a situation, and we already have a situation, with very high prices sometimes, and more very low prices, and all the time extremely high fluctuation. This is how the market looks like, and that's a short run marginal cost, the one at the left. Would be wind power, where this, because wind costs nothing, so that the market, marginal cost for the first piece, which is wind power, and solar, will be very low, and then you have nuclear, which is very expensive to build, but rather cheap to use, and then you have different types of coal, and then you have gas, and in this case you have the price, you have consumption. I think I can this, okay. This is a demand, and if the demand cuts the production here, where you have a sort of coal or gas plant with this cost, you can see the cost is out here. So the supply and demand, supply is this staircase, and the supply is then hitting the demand curve, which is this one, at the first rather situation, spot price in the first situation, it could be a rather high price. Then you have a lower demand a couple of hours later maybe, then the price will be lower, and then you have this price, and because it is always the highest price that sets the price for all the others. So if this is the price, then wind power will also get this price. So all these producers who will produce in this situation one, they will all get this white space also as a price, so they will have some surplus. It's good for wind that are expensive natural gas plant, and we have to use it. So, but it's bad. If this is wind power, then wind power would, in situation 2, would get this price, also up to here. And this is what is called the running cost, you could say. And then you have the investment cost, and then you have the profit, if there's a profit. So that's how it is now to a big extent, because it has been now, because very often the price is set by more expensive units as wind power, but it's not what's coming. Because what's coming is that we have more and more renewable energy. If you take fossil fuel, then you have to build a plant, but you also have to buy fuel. So the price will never be lower than the price of fuel. It could be, for instance, 50% of the kilowatt hour price, and the price will never be lower than this. Clearly, you will not, if you have a coal plant, you will not sell electricity cheaper than the coal you have to buy. If you have a renewable energy production, the cost of building it is rather high, but and then you have very low short-run marginal cost, because that's just to keep the wind turbine or solar energy running, and so we are in a big shift from 50% building and 50% fuel to 95% capital cost and 5% running cost. That's a big shift. And as it is the running cost that sets the price, then this shift is also resulting in very low prices. That's what I mean by wind power committing suicide. Because the more wind power, the lower price. And that has been like this for the last 10 years. And so you need to change the market so that the market does not kill what we want to have more of. So if you have increased wind power, now you can see this low one is longer. So you will have a price when we use a lot that's defined by gas or coal-fired power plant, and then you have a price when we use wind turbines, which is then defined is then the price made by this, and it's low. And it's only the running cost, nothing to recover the investment cost. So it doesn't really pay to have a wind turbine if the price develops like this. So that's renewable investment cost, and it's a loss in this situation too, because you don't recover your investment, you just get a price for running, keep the wind turbine running. Okay, this is a little bit complicated. I will not say a lot about it. It is in fact not complicated, but it's complicated to say it in a few minutes. It's just showing that the amount of hours where wind power is producing all what we need of consumption is increasing. So in 2023, and this is just a rough estimation, its amount of hour would be around 2,000 or 1,600. And later on in 30, it will be around 3,000 hours per year, where you have the very low price. And if you go further on and have really much wind power, it would be maybe 5,000 hours per year, where we have a very low price. So this is the process of a technology with this cost distribution, 95/5, is in a way, it does not really pay to invest in it on a long term if we don't change this market. That's the same figure as before, but you will see that you have now we have a really long field of low prices, because this is the running cost of wind power, which is very low. Investment costs are high. And then you have different demand. This could be in the middle of the day, and this would be later when the consumption is lower. And then, so you have really many situations. The red ones are many situations, and red means red economy also. Then there will be more of these situations all the time, because this piece has been longer. Before it was here, and then there was a staircase here. We will have prices up here. But now you have a big piece of production that's wind power, and that's what we want to have. But it's we don't have good markets to support it. So if we end up with this, we will have a loss of investment cost because we don't recover. So we might, now I'm just painting the black paintings or the red painting, we might really have a situation where many wind turbines cannot, and solar energy cannot keep the economy running because of this market construction. But it is not totally sure that I'm right in this. I think I am. It depends on to which extent the consumption will increase at the same space. If there really is an increased consumption, if the consumption is doubled within the next 7 years, this might keep the price of wind power higher, but I don't know how this could happen. It's really not 7 years. We all know, many of us know, that we are not often talking about 7 years. We are often talking, now we're talking about 40 years. And I've been here around for these kind of things for 50 years. And so things takes time. And you cannot just within 7 years more than double wind power production and then also double consumption by building a lot of carbon power to X power plants. This will not be easy. Okay, that's just The future there are three tendencies I already mentioned, and I'll say it very quickly or briefly. Price could decrease for wind and solar power, and then there could be increase for electricity in the period where there is no wind and solar, and increased fluctuation. I already said. I already see that I'm repeating myself already after 15 minutes. And this is just showing the price on North Pole since electricity. That's 2021, and it starts increasing already at the end of 2021, and then it really increases, and it increased in the beginning also at the end of 2021, and then it increased a lot, and now it's going to look like this because of the things I just mentioned before. And this is what this is just saying what the EU think will happen. We have 198 think and want 89 gigawatt in 2021, and and it is required due to the policy of EU that this should more than double in the next 9 years, 9 years from 2021. And what happens is supposed to be not a doubling. And the problem is, will consumption increase with the same speed and in the right way in the same period? Which policy, which markets? The Danish power policy agreement on wind power is, as Poulsen was talking about, it's 9 gigawatt offshore wind power in 2030. On top of that's offshore, on top of the 2 gigawatt we already have, and 9, and then also I think 4 times on land capacity. I'm not totally sure. It should be on market conditions, and I don't exactly know what they mean by market condition. But it is a big increase. It's around 10 gigawatt, and if each gigawatt produces 4,000 hour full load, then it's 40 terawatt hours, a million kilowatt hour, I think. It's more than a double of the present consumption in 9 years from now. That's what the Parliament says we should produce, more than a double of our present consumption, and that's what Poulsen was talking about, that we will have to export a lot to power to X, I suppose. So, conclusion 1, increasing, you know how much time is left? Du prikker mig simpelthen, jeg får det prikket ud af position. And I think you're also soon becoming hungry. And that's the best time to have a presentation. That's when people are sitting and thinking, could we soon get something to eat? But okay, that's conclusion 1. Increase share and share of this where you have a high investment cost and low running cost. And this gives low prices. And so there will be an increase in the number of hours where solar and wind is setting the price and the price is low. This can result in years with overcapacity and very low price, and because you have to coordinate supply and demand, and if you build a wind turbine, it will stay there for 30 years. You cannot just say, okay, we built too many wind turbines, so we just close them down and remove them and say nothing happens. So you have to, so we really invest in something, and if the consumption is not there, then the price will be very low. And the price can be very low for several years because it also takes some years to build new consumption. Therefore, there is an increase, and that's the main message, to synchronize the consumption development with the expansion of renewable energy capacity, and this is not really happening now. And then I have a loose proposal, and that's, I think I have 2 slides or something left. And that's a yellow one, that's just proposal for the market, and it's not far away from it's what they are discussing in the EU for the time being. in order to avoid long periods with almost zero or even below zero energy electricity prices, there should be a bottom price, and that's this one of 2 euro cent, at least 2 euro cent per kilowatt hour, so it's never cheaper than 2 euro cent. Because this is closer to the long-term cost of wind power also in the periods where there is too much. That's a big discussion. And then there should be electricity tax on the share of electricity prices that are above 12 euro cent per kilowatt hour, so there should be a sort of ceiling and a sort of bottom. And then so that we avoid this totally wild fluctuation. This the money coming from this tax should be used for reduction of consumer prices for low-income consumers, and there should be a public guarantee for investment in energy conservation, and there should also be public subsidy to establish flexibility in energy consumption. And the way of financing it is a tax coming from this, so it's not more in income tax, it's more in energy tax. And then this may also, these euros, because there are many periods where the market would end up lower than 2 euro cents, but producers should get 2 euro cents, and this difference should be financed by means of this electricity tax. And then this is rather close, but the EU has not agreed on their model. And the Danish energy organization don't like this model. They like it as it is, and as it is now. And then this is an interesting point, I think. That's a coordination of consumption and production. There should be a mechanism where investors in wind power capacity can only get permission if they have a contract with consumers. And where a new large consumer can only build a power-to-X plant if they have a contract with wind or solar power producers. That's it could be necessary, and I think it is necessary to do something like this. And then the next suggestion is coping with energy system resilience and robustness, and all the problem of that central offshore energy system are unsafe or unresilient due to sabotage or technical accidents, war, economic problems, natural disasters. And therefore one should, where possible, build onshore capacity. And there should, and that's totally out of the wind power discussion, establish and accelerate energy conservation activities, because conservation is the only really resilient as a robust energy source. And establish a resilient role so that local cooperatives and what's happening inland is having a sort of collaboration with the big central system, so that they together can handle if there is a big problem, sabotage on offshore wind power outside here. Then there should be an agreement with all local system. How do we handle this situation? And it should technically also be found out how to handle it. I think that this combination of central and decentral should be coordinated, and I think that Folkecenter could participate in designing new version of a resilient system where there is not only either the village or cooperatives or the big offshore, where they are forced to collaborate in a way that when something happens to the big system, the small system can take over. So that's just a suggestion for the next 40 years. Maybe for the next 10 years or 5 years. And yes, that's all for now.
Thank you so much. So they said thank you to you.
Yeah, they're very polite, these dogs.
Yeah, they're very polite.
Yeah.
So it was our talk from Frede to Frede Hvelplund to all of us, and thank you for that. Some questions? Værsgo, Kai.
Yes, I have one. We know that the wind won't be there at every time. So therefore, I think we in UA have to get a strategy before we know that, and we also within this know that if it doesn't blow there, it can blow another place in Europe. So I think it's necessary to find out where we have to design which countries we have to place the windmills to get most out of the wind energy in the EU.
Yes, that's. I agree. I think we should do as much as we can at home, so that we have and then we should have a transmission line between EU countries, but less than the Minister of Energy or Energinet is saying, because they don't really use the potential of producing locally first. But I think I agree with you. And I don't think that we should just have a system in Denmark and then a system in Germany. I think we also can, by means of offshore, if we can find systematic collaboration with German users, we should maybe produce hydrogen for German industry. If we can, because we have offshore capacity that's much higher than many other countries have. So we can produce a lot. So to some extent, I think that I think that it is. We should not just produce for Denmark. I don't know what you meant, Poulsen, but I think that we should produce what we can for Denmark and then find good solution to have our surplus production used in good ways in Germany and as export. So these 17, but this I totally agree. This whole plan of doing this has not been settled, and we're talking about it as if we know how to do, and there is no really, to me, my opinion and the little I know about it, there's a lot of chaos and wasteful thinking. Because in principle, I agree with you, what you're saying, but what are they exactly planning with regard? Are they having this infrastructure for hydrogen transportation to Germany, and do they have agreement for that industry? Are they ready to use it? All this should be more much more well planned as it is today. Now it's a sort of to a big extent, wishful thinking. There has to be fixed plans for it. Yeah.
So thank you, Kai and Frede, for your answer and your questions. And now we are a little behind the time schedule. So it means when we go for lunch, we first start again 2:15. And yeah, I have one more message. the people that are vegetarian, they go to the dish where Helle is responsible, and there will the vegetarian food be, and on the big table there will be the meat, there will be the food also with meat. So thank you, and we meet 2:15. Okay.
Yes, you do. You do. You say what you need.
So welcome to the afternoon section. And the lady that are in the program will come after Anja Krenz. So we changed the two speakers because Kirsten Hasberg is on the way in train. Okay? So we start with Anja Krenz. That is number 2 in the after section. So welcome Anja Krenz, and we will ask you to make a speech for us.
Thank you. Thank you. Can you hear me with the mic? Okay, you can hear me. Hello everybody, thank you for having me today. It's a lovely pleasure to talk. Is the mic okay? So today we will talk a little bit about art and wind, and a little bit about politics as well, and some of architecture. Okay, so the year I was born, let's not think when was it, but that was the year when Preben Mergård introduced his idea for a component wind turbine. That was the time. And when Folkecenter opened some years later in '83, I was still living in a communist country, Poland, that's my homeland. And Poland was occupied or colonized for almost 200 years by different regimes. And that last regime, which was the Soviet Union, I grew up under it. And the life was kind of dull and gray, and we did not have many things. There were rations for food and black TV. And I must say, I'm using some of Preben's photos, which I have a huge collection. So Preben's photos from the time illustrates the reality. He was visiting Poland at some point, apparently, because it's his photo. So it was kind of gray in Poland, yeah? I must tell you, the color palette was, it had special, I mean, communism and socialism had a special palette of colors. Back in the day, yes, Preben's photos. But you see, okay, then times have changed. The Polish movement, it was workers' movement called Solidarność, Solidarity. They tore down communism in '89. Soon after, the Berlin Wall followed with a little help of Preben. That's the Berlin Wall. So it fell down, yes. He had his role maybe in it. His photo. And when I finished my university, I studied architecture. And there where I met also Arne, Preben's son. So when we finished our studies, then I didn't know what to do in life. And Arne said, oh, just go to see my father in Jutland. And I said, okay. So I came here in December 2001. It was very dark and winter in December. I knocked on the door. Janne and Preben opened the door and they say, hello, hello. And Preben asked me, okay, what can you do? And I said, I can draw. Okay. And that was the year 2001, and that's how I stayed. Well, not physically, I come here every year, but our collaboration is already 22 years long. And it started with drawings. I will give you some examples, because that's what I do. I'm an artist, so I draw. And I think it was important that within this creative process we've had with Janne and Preben, when Preben was telling stories, and you know he could tell stories, I was the one translating these stories into a drawing. He was talking, I was drawing, and it was kind of a very unusual situation because I was a young woman from a communist country, which was I was on the lowest step of any social ladder back then, but we could communicate together, and it was a cultural shock when I came to Folkecenter. The shock was that I was respected and welcomed as a person on the same level, and it did not happen to me before. Because again, being Polish at the time, there's this word I forgot, discrimination. I could experience this, but not at the Folkecenter, and that was really a shock, which then made me think, is a different world possible, like this one? Apparently, yes, it was here in Jutland. So Preben was talking, I was drawing and illustrating different ideas about acceptance of wind turbines, ownership. Why? Well, because, I mean, sometimes I think, well, it's when we talk about things, and some of these things are very technical, and many people don't understand the technical part, or maybe the subjects are boring, or I don't know. But with a drawing, my idea was to make it so that anybody can understand it without words, like the drawings for Light over Mali. I mean, I hope we don't need any text to understand what happens, because when Folkecenter is going out to the world, there are people speaking different languages, and with a drawing, we can skip the words part, the language part, and we can communicate through drawings. Besides, these are some of the early drawings, and I don't know if you remember the year 2002, yeah? When your Danish minister, Fogh Rasmussen, he canceled all the money for renewable energy. Then, of course, we had to react and draw something about the situation. I read recently that Rasmussen, he apologized for this situation, so he's fine. We can still. So these are some of the early ones. And the drawings were helping Preben also and Janne to, exactly, this is a minister, Joachim remembers the name of him. There was one minister visiting Folkecenter, they were discussing and talking, and the drawings were helping. Well, I don't know. Because, Ligord, yeah, Ligord, yeah. You see, for us artists, I think our mission is exactly to talk about difficult things, to make people see things differently, to change the perspective, to go out, to talk about taboo subjects. That's our mission. That's our right, but I also think it's our duty to comment on reality. And yeah, also my son was also part of the drawing adventure at the Folkecenter, and also Denmark. My son is not here, he will come in July. So, art, because we cannot forget, before Folkecenter became Folkecenter, this place was an arts and crafts center. That's how Preben founded it, but you probably know it. It was more art and crafts, and after the oil crisis, when things changed, and you, some of you, the wind energy pioneers, you had to think, what can we do because of the oil crisis? And then the Danish concept and wind turbines were developed. But before that, you can maybe even see, this is the office upstairs, that's Folkecenter before it became renewable energy place. Before it was art. That's why maybe art has such an important place at the Folkecenter. Even now we are in Bjarne Nyborg Museum. These are Bjarne's paintings. So I think the connection between art and renewable energy and Folkecenter is so important because it is rooted even before Folkecenter was Folkecenter, when it was still Asgård, the training center. I think this is a fantastic history because, you see, during our talks with Preben, I was telling him about some of my activities, recent activities in Berlin. I'm an activist also, and I'm fighting for women's rights in Berlin, and also for women's rights in Poland, in a country where we have a very strange government run by a political party called Law and Justice. They are right-wing, like in some other countries too. They don't like women. So when I do my protests in Berlin, they are usually artistic, all right? But then I was telling this to Preben once, and I said, yeah, you know, Preben, I'm doing this and this in Berlin. I said, great, fantastic, but being against is not enough. You have to offer an alternative. And I said, you're right, because that's the story of wind turbines here. That's the story of Folkecenter after the oil crisis. People were saying, oh, we don't want atomic power, we don't want coal, but what should we have instead? And people like some of you, the wind energy pioneers, you developed an alternative wind power that we know today. It's a global thing. But these words that Preben told me, I really took them to the heart. That being against is not enough. It's true. So can we create the world? Can we as activists or artists, can we have our Danish concept? What would it be? What is political activism? Why do we need it? So of course, as an artist, it's easy to create and offer an alternative, but also as an activist, I founded some organizations and networks which make sense for our feminist movement, let's say. It's all connected, I must say. But I really have these words in my heart from Preben. Because then again, some years ago, when Preben asked me, "Oh, Anja, would you like to make a book with me about wind power?" And I said, "No, I have to think about it." I slept over and I said yes the next morning. And it was a 2-year-long adventure to write this book, to edit, to translate the wind power for the world. We spent really 2 years on it, writing, reading. And maybe I'm the only person who read the whole book twice, since I translated, edited, wrote some of it. But the story of wind turbines, which Katherine was already mentioning before, and I'm still using Preben's photos, or some of you, they are fantastic pictures, which illustrate the story. But again, the story, how these wind turbines were developed. Why would we need this history? I mean, okay, today the wind turbines are already developed, made, but we need this history to see that things don't come just overnight, that things take time, and it's an amazing process of trial and error, how some of you developing the prototypes were trying, put them on a car, driving, developing wind blades. It's a fantastic story. I think we do need history. Also the history of wind power. It should be told even more, because for example, like if you read some Danish or international media recently, there was no one father of a Danish concept, as some mainstream media like to say. There were many of you, many people were doing it, and I think we should all remember, not necessarily to give a credit, but just to remember that it was not just one guy who now runs a huge company with patents and huge wind turbine business. He was not the only one. There were many fathers and mothers of the Danish concept. Yeah. People were trying. Can we try things as well? Even if we don't succeed, we should still try to find an alternative, like the Danish concept, exactly. You probably remember it from the book or from the flyer. Thank you all, wind energy pioneers, because thanks to you, to the years of your hard work, your passion, we can have wind turbines all over the world. And this is an alternative which came from here. That's why I'm so proud to be here. And for example, it was also Folkecenter that installed the first wind turbine in Poland in '91. It was a 95 kilowatt wind turbine in Swarzewo on the coast. Exactly, that's the opening of a wind turbine. So it was Folkecenters in my country, Folkecenters action. And the book we made, yes, we went around the world a little bit. We went to China with Preben, gave lectures and presentations. We also went to Paris to promote the book. And the situation in China, it's a little anecdote, I can tell it. Nobody will know. It was funny because it was a conference about non-grid wind energy. And suddenly Professor Gu, he said to me, tomorrow you will have a speech. And I said, all right, no problem. Whatever, I can speak about anything, I just didn't know what about. Preben said, I will speak about our book. And I said, so what should I speak about? I mean, all right. And Preben said, just speak about Professor Gu. Okay, Professor Gu. Then I spent the whole night researching what is Professor Gu doing, and I made this little presentation about energy pioneers, Preben and Professor Gu. But the thing was in China, at this conference, I was the only woman. There were like 100 Chinese men, and then when I was listening to earlier speeches, I thought, what? Why are these people so angry? Is there something happening when they spoke Chinese, shouting? I said, what is it? But then I realized that's the way people in China speak. They are loud, and we think, oh, they are angry. No, that's the way they speak. So I thought, I'll do the same. So then I was speaking loudly, shouting about Professor Gu. Some of them woke up, but yeah, exactly, I had some fun of these 10 minutes of shouting to the Chinese men about renewable energy. It was fun. So we really had good time with Preben. He was a very cool trip companion. He made me go there. Yes, So, that's somebody else. If you recognize Janne, that's you. Yes. You see, these are again historical photos, which I have many, and I think it's interesting to see this in terms of today's situation. When this photo of Janne is from, you had to have a trip, I don't know when, but you went to Chernobyl to protest against atomic power. So that was the Danish or international movement against nuclear power, which was successful in Denmark. Well done. Later, it must have been later that I see Preben going to a Polish location of a nuclear power plant, which was luckily not built back then in Żarnowiec. Yes, because unfortunately this, you in Denmark, you fought against atomic power, you don't have it. The Germans, they just closed their last atomic power plants. But Poland, what is doing Poland? They try to open a new one. Well, not open, build one, which I hope will never happen. But exactly as we speak, today is Friday. Tomorrow, some Polish activists will again protest against atomic power plant in Poland. Not only because of it's dangerous, because of Chernobyl, because of Fukushima, or the war in Ukraine. But the Polish government is so unstable that nobody trusts them that they can do it properly, and it's very expensive, and this pro-atomic lobby is really spreading all over, also in Poland, and it's also a politically wrong decision, I think, because, yes, we will see why. Because what happens now with the war in the Ukraine, yeah? What happens now as we speak, these articles are from, I don't know, yesterday, there is a risk. First, the Russians, they blew up this dam in Dniepr, on the river Dniepr. The water went down, and there is no water to cool Zaporozhye power plant, nuclear power plant. The water dropped. They are trying to supply some water to cool it, but it will probably be gone. And the latest news, I don't know if they are real. We never know if it's real. But if it's true that the Russian army, Putin's army, wants to blow it up, the whole nuclear power plant, then we are really in trouble. That's why if people build nuclear power plants, they have to realize it is a political issue. Energy is a weapon. Energy is like gold of all days. It's a value. You see, like all the wars we've had in our region, in the world, these wars were either because of resources, land, slaves, humans, religion, very popular reason to kill other people. But there are also wars because of energy, oil, or this is part of a war game. And we all are at risk. Probably in a few years there will be wars because of water, which is a scarce thing that we might not have. Maybe because of migration, we'll see what climate change will bring us. But at the moment, as we speak, it's a risky situation. And exactly, these are the protests in Poland. The new power plant should be located in the north of Poland, where, I don't know if you remember, it was a month ago, there was kind of a military exercise a little bit south from there in Poland, because now we have a lot of military from US, from different countries, because of Russia and Ukraine. And there was one exercise that was so strong, I don't know how, that people in Bornholm felt it like an earthquake. It was a month ago. The windows went off. It was because of whatever military thing they did. And that's where they want to place, on the shore, that's where they want to place a nuclear power plant. Well, all right, no. So many people are against, but there is also strong lobby for atomic power. The word tak in Polish means yes. So tak for atomic power, no to atomic power. And so tomorrow there will be another demonstration in the region. Because imagine having a country with a very strange government, like Hungary, like Turkey, maybe Spain, hopefully not, some kind of Italy, Poland. This government, on one hand, they want to build a nuclear power plant. On the other hand, they did promote renewables. in my area, there are many, many wind turbines. So Poland does have many wind farms. We also have a lot of PV panels, even me, because there was some subsidies for it. And now the best business in Poland is to buy a piece of land, put a PV farm, and then you just live of it for some years. But this government, they change the law every few months. So it's difficult to invest in a longer term because you never know what can happen. They might suddenly change. There was a law, for example, for wind turbines, which was quite open. People invested in Poland, but then the government said, we should destroy something. Let's destroy wind power. So then they made a new law which said, I don't know, that the distance from a house to a wind turbine has to be 10 heights of a wind turbine. And this law blocked many investments. They changed it again 2 months ago, probably 7 heights, I don't know. So you never know what can happen. That's why people have to be always aware and try, if you want to invest in renewable energy in Poland, you have to be patient and smart, because you never know. And these wars, like what Ibrahim was talking about yesterday, because Ibrahim was talking about women and energy, and it's true that women traditionally are the keepers of the home. Traditionally, and the most of the world is traditional. Yeah? So we take care of the house, we cook, some of us clean. All right, yes, but this cooking, this taking care of. And when we see wars, which are made by some boys, adult boys, which always have to fight, they never grew up from their childhood war games, these people have to fight, then who is the victim of it? Mostly, of course, women and children. That's how it is. If we talk about wars, of course, there is violence, there is all the war crimes that we can imagine. And after the wars, it's usually women who clean the mess after it. That's why it's so important that we really support women within energy, because they are the keepers of the home. It's of course sad that we have to talk about the very simple division, that somebody is destroying something, somebody is building something. But that's how our world runs in a way, if we see it simply. That's why, for example, Lisa was mentioning that when we went to Mali, to Ibrahim's conference, we also visited the village where you installed a wonderful PV installation for the pump. And then you see, I'm an activist. I had this transparent, this Women of the World Unite. I always carry one in my bag. You never know if there is a situation. Even I took one even to Africa to show it. No, because we all are kind of similar. We all struggle with similar things, regardless of the country we live in. In some countries it's worse, better, but we are kind of all the same. So that's why it's important to support the women, because it will be just one sentence about women. Oh, imagine, it's only 100 years ago that women in some of the countries got voting rights. Before that, we could not vote at all. We were not part of any system. It's quite similar with education. In some countries, like Poland, women can study since more or less 100 years. So we have a lot to catch up, to catch up with the civilization. But look, I made this list yesterday, and it was so interesting. Okay, I'm not talking about small little countries which were the first, but it was New Zealand, 2015, Saudi Arabia. Well, but they don't vote anyway, because it's, who cares, no? If in a monarchy you don't vote, there is no reason, but officially women can vote since 7 years. But well, yeah, Poland, Denmark, you were quite early with a vote, like classic. Poland was Germany a little bit. It's not much. Look at Switzerland, 71. Quite late. But that's how it is. This is reality. These are the dates. So we really started to be part of an active society quite recently in some of our countries. That's why supporting women, because it's time. It could be fun anyway. Now we will go to a different country. Now I'll tell you shortly about a trip I made last month. why? Last month I went to Venice for the opening of the biggest architectural exhibition, Venice Biennale of Architecture. And normally, this exhibition, it's big. Yeah? It is opened every 2 years, and all the architects are there. It's like, okay, fantastic. But this year, it was different. Because this year, there was a woman who was a curator. She has her roots in Ghana, but she also in Scotland. She was born in Scotland, but she's from Ghana, her parents, her family. And that was different. Things are changing. In architecture, maybe a little bit slower, because architecture, you build it long, it stays long, things might take more time. But for the Biennale, it was the change. And you can see it. Not only, the thing is, Biennale is made of 2 elements. One element is a huge exhibition, which the woman Leslie Loco, she called the exhibition Laboratory of the Future, and she invited mostly architects and artists from Africa. Over 50% were people from Africa or African diaspora, which is unusual for architecture, to have a place for people who are not famous architects from the West, global North. And the average age was like, I don't know, 37, quite young. Half of them were women who took part in this exhibition. This is new. This is really new. And what was interesting at these exhibitions, some of the projects were classic architecture, but there was a lot of projects which were dealing with the 2 subjects she proposed. One subject was decolonization, important at the moment. It's a very important discussion in the world at the moment, and decarbonization. Both very crucial themes for the day, and the answers were coming not only from architects all over the world, mostly from Africa, but you could see projects which were not directly architecture. It was research projects, it was ecological projects. Like, you could take whole Folkecenter and exhibit it there. This would be part of it. It means that if we can call it mainstream now, since May, since the opening, if these things, what do we do at the Folkecenter, if this is part of the mainstream architecture, and Folkecenter does it since 40 years, it means we were ahead of time, and we are exactly in the global trend of fighting with climate change. And Folkecenter has been always offering solutions, and you can see that in other parts of the world people do the same, because we have to do it. We have to find solutions. So you see there were some quite cool projects of African architects, like Adagye. He made this installation. The architect and artist, Dmasten Woko, he got a life, it's a prize that they give at the Venice Biennale for life achievement. He got this prize. It was really quite interesting. I really recommend you to go, but take a few days in Venice to see this exhibition. Even Denmark had a nice exhibition, because the other part of this Biennale, some of the countries, they have their own pavilions and they show what they do. And this is Denmark. Yeah, the Danish pavilion showed a research project about the coastal areas of Copenhagen. It's quite interesting, but it was research, less architecture. So that's the newest trend in architecture. Or Romania showed my favorite exhibition. Well, they showed prototypes of early electric cars. What does it have to do with architecture? Not directly something, but that's how the newest contemporary architectural practice looks like now. That's what we talk about, cars or early forgotten models of wind turbines from Romania. Okay, so you could see many, many things. German pavilion was also quite cool, because they did not make any new exhibition. They just took material from last exhibitions, you see, and they said, okay, reuse it. They showed physically, okay, this is the waste from previous biennales, let's play and use it. So I think it's quite important to talk about architecture, because this is our built environment, and this is what we do at the Folkecenter since 40 years. Yeah. So we took a little trip around the world. There is another, exactly. I put this slide today because I woke up and I said, no, no, no. What you saw at the Biennale in Venice, okay, woman from Africa, African projects, small practices, small offices. Where was the white man? Where was the star architect? Oh, they were there. You know what they did? All the famous architects, we call them star architects, all the big ones, big names, they thought, oh, we were not invited to Biennale, let's make our own alternative exhibition. And in front of Biennale, they rented some palazzo, and they presented this new project they all work on. And it's called The Line. It will come in Saudi Arabia. It's a city like this. You can see it on the model. It's not built yet, but many, many big architectural offices are working on it. Many. Only Lord Foster, famous architect, he said no, because one activist was killed, murdered, who was protesting against this development. Then Foster said, no, no, then I'm not taking part in this project. It's oil money from Saudi Arabia. It's like $500 billion investment. That's how it should be inside. It's completely crazy, but not sustainable. People criticize it about it. Yeah, not only it's not sustainable, but people are being murdered along the way. It's oil money. So white men architects, star architects, they presented their new project, and I think this comparison between what's local, what's bottom up, what's indigenous, what comes from small communities, the research we saw before, clashed with big money, with oil money. I think it's a very cool example of showing how our world is changing. It's not so simple, black and white or green and yellow. It's not that simple too, but it's a visible trend to where our world is going. What we do at the Folkecenter, we are doing the bottom-up thing. Roshan Bilimoria, she was one of the people who worked on a project on a project in the 70s at the Folkecenter, which was called CHU project, and the idea was to promote this region and make it green. She was the one, apparently, who said, think global, act local. It was her words, which we all know today. Yeah, they were coined here. Or did I say it right, or the opposite? Think local, act global? Yeah, both works, no? Actually, exactly. But it was here, you see. So we are the place which is so innovative and so visionary and ahead of time. Things were started here, and now they go in the mainstream. So thank you, because it's, especially Jan, I wanted to thank you for, when I was talking about women, you are one of these examples of a leader, of a person who can have an overview, who can manage, who is a wind energy pioneer, who is devoted to the cause. And that's why I thank you, because you are so cool, you are such a wise woman, you are a role model for many of us. Thank you. And yes, I wanted really to thank you and give my gratitude and hope that, yes, Prem's photo. Thank you very much. Thank you.
Tomorrow and the day after we have excursions, and we have a number of people who sign up, but we would like to double check that, so if we need to get a big bus or a small bus. So later when we are done, if you please come to me and then we make a check.
Do you think we should send it around each one?
That's also fine, whichever.
So, but we will ask you friendly to do it, so that we know how many people we will be on the bus and how many people will go for the Hotel Felipe.
Okay.
No.
So we have to
Yeah, also, yeah.
maybe 25th as well.
Yeah,
Yeah.
yeah. 25th also. So, thank you. Sorry, yeah. So our next speaker will be Kirsten Hasberg, and I have to say sorry that I stopped I took my phone on not hearing calling, and then Kirsten was calling from the station, and I'm very sorry for that, Kirsten, but it was good that you come and will talk to us about what you are working with. Yes.
Ja, det prøver jeg lige at give dig også. Du får lige den ene her først. Fordi vi har en både til rummet og en til kameraet.
Den er ikke... Og havde du også... Okay. Perfekt. Great, okay. Tak, Jane. Tak. Det er godt. So, my name is Kirsten Hasberg. I'm really happy to be here. Sorry that I couldn't attend earlier on. I was at the Hybrid and Electric Marine Conference in Amsterdam, which is about electrification of the marine sector. So I took the trip from there, and I'm very happy to be able to talk to you about energy democracy and the green transition in the educational sector. There will be a little language confusion here because I did my slides in Danish, but I think that fits quite well with the mix in the audience as well. So, I've known Jane and Preben since I was like 17 years old or something like that. And it was through Jane and Preben that I got to know also Hermann Scheer, who I worked for in 2005. So I really kind of grew up in this, the spirit of the decentralized energy transition. And today I work with Danish secondary education institutions who all want to do more on the green energy transition, but sometimes have difficulties realizing that both in their buildings and in their teaching. So this is a little image from my Ph.D. which I did and with Frede as my advisor. Basically, I see the green transition as this transition from a storable system and a system where you have fossil energy that can be stored and that can be managed in a relatively easy way, to a system where you have fluctuating renewables and a lot of more communication and information that is needed in order to make the supply and demand fit. And I tried to illustrate that with this phone line on the first slide, here, which is, the fossil energy system used to be really simple. If you need some more power, the grid operator would just call up the power plant and please ask for one more shovel of coal, right? And that system is now changing into what we often call smart grid or intelligent energy system, where we have a lot of more interaction going on between a lot of actors that are part of the energy transition. And one thing which I think is becoming increasingly important is that
we need to see this transition from the fossil to the renewable system within the context of the planetary boundaries. This is not only about green growth, but really about resilience and sufficiency as well. So I'm going to focus to some extent on solar energy today because that's been some of the education projects that I'm involved in. That's been their focus because it has a scale that means that it's really easy to involve students readily, while wind power is, at least in Europe, often at a scale where it's not something that is accessible or readily something that allows a readily involvement of students. So let me see. Of course, we've probably seen this a lot of times during the past few days, or anyways, it's common knowledge here in the room, but the reason that solar has become so interesting for everyone is, of course, the strong price digression. Here it's only shown up against the levelized cost of electricity in a comparison with fossil gas. So just the two sources, not to make the image too complicated. And you can see that the lines cross, well, also due to the price increases in gas, but primarily due to the strong decrease in the solar photovoltaic price. I'll come back to well, Anja already touched upon it briefly. She said the best thing you can do in Poland at the moment is to get a plot of land and put solar on it. I'll come back to that has upsides and downsides as well in the agricultural sector. Well, but yeah, I think this is even already an old image. It's from 2021. Fraunhofer updates this yearly. But really solar and the big utility scale solar especially is the cheapest energy technology. This is seen from a German perspective, so it's slightly different from countries that have different, like slightly different would it be here. But this is the general tendency that we have wind and solar totally outperforming everything else. So, nevertheless, solar is actually still only around, I guess, 5% of the Danish electricity generation. And within very short time, the political goal is that this should increase tenfold within a few years. This is a political agreement from last year. You could say that the solar craze, which other countries may already have experienced in earlier years or decades, I'm looking at our German guests, is now coming to Denmark. And the question is, of course, how could we do this in a way which is beneficial to the broader population, and not only beneficial to the few. So what I've been working on in the past few years is to work with the educational institutions, primarily the secondary education institutions, that is high schools and vocational schools. It's not because I'm not interested in younger or older pupils. It has a simple economic background. This form of schools in Denmark are self-governed, which means that they can make their own decisions regarding their buildings. That's very different from the primary schools, which go up to 9th or 10th grade, which are municipal. And it's also different from the universities, which typically have rental buildings and not buildings that they own. So for this simple reason, the vocational schools and the high schools are really nice to work with because they can actually make decisions regarding their own building, regarding their own energy supply, which is a bit different from both the schools where the younger pupils attend and also different from universities. What makes energy all of a sudden a very interesting subject to integrate into teaching is that we had a complete rollout of intelligent energy meters in Denmark, which was completed just recently by the end of 2021. And with this rollout, it means that every consumer, large and small, has access to their electricity data hour by hour. So you can follow your consumption. You can still only follow it with a slight delay, but you actually have access to detailed information about your consumption. So all of a sudden, this opens the possibility of using your own electricity consumption profile over time in your education instead of just having some kind of time series data or some simulated data or some emulated data based on an annual consumption. So there's much more fun to be had with your solar data, basically, or even if you don't have solar on your roof yet, there is much more fun to be had in looking at, okay, when is our energy consumption high? When is it low? At what price are we buying it? How do the prices differ in different hours? So this means that there's a lot of pedagogical potential, so to speak, in using energy. Now I'm talking primarily about electricity again, but it's because data is more readily accessible on electricity than on heat. So why would we want to have the green transition in education? Well, this, of course, education for sustainable development is an old concept, but I focus primarily on three maybe more short-term reasons than what the education for sustainable development idea has proposed. This is a professor of education who very prominently in the High School Teachers magazine stated, well, if you really want to do good climate education, it's a good idea to include the school's own operational initiatives in the curriculum. So not to separate these two, to on one side have building operations, get solar power, do energy savings and so on, and on the other side try to do curricula for sustainable development, but really to integrate the two, because that means that for the students it has a direct relevance when it is the building that they are studying in every day, which is the case study, so to speak, for the energy transition. It makes it less abstract and more concrete. This is the wrong direction. Wait. You can also see it from the operational perspective, especially since the electricity and energy prices went up so strongly. Many schools are in financial difficulties because of increasing energy costs. These are restrictions, like this forms of restriction on schools, which might even be stronger than other problems like smaller youth generations coming up and less turnover because of that. So energy costs, especially for the vocational colleges, is actually a big part of the budget. So for that very practical reason also, it is important for the schools to look into their energy consumption and their energy costs. I'm not sure. Oh, no, it's working again. Perfect. So last but not least, especially for the vocational schools, this has a very strong labor market perspective as well, because we all We all want the green energy transition to happen, but at the moment the question is, who is actually going to do it? This is the quote in the lower right corner. We are really in lack of skilled labor in many sectors, and especially skilled labor that is able to actually do the energy transition is missing. So just in the solar sector in itself, as you see this quote from von der Leyen, the solar sector alone will require 1 million skilled workers, and this is a big challenge. So that's yet another reason that the schools could be at the forefront of the green transition. So then you could of course ask yourself, but what do the students think? Are they interested in this at all? Now this is an image from the Instagram account of my own former high school, Nørregymnasium, who also happened to be my first client. I talked to them just during the process where they were about to get a solar rooftop installation. You would think that that's a pretty straightforward and easy process, but again, a school is an educational institution. They're not really used to managing larger investments in their building. So actually it was really difficult for them to find a good supplier, a reliable supplier, and to get the project going. So I helped them a bit with that, and this is the moment where the installation was up and running last year around this time. There was a public Danish radio journalist who came to the school to interview one of the students, and I gathered some quotes from her because I think the way she phrased it was quite interesting. So she's an 18-year-old student who is in the second last year before her high school exam. And she comments on this step of the high school to become more sustainable and to supply around 1/5 of the annual electricity consumption by their own solar system, by saying, well, in the primary school, you learn, and this is interesting, you learn about the right and the wrong types of energy. So it's really cool to know. Now I'm here at this school, and we learn a lot about energy and green transition and so on, and then we have solar power on the roof. So you can be here with a clean consciousness, so to speak, and you know that you're part of a good future for the school and for the environment. You know what's going on, and you can pardon? You can vouch for that. Thanks. So that the good and the bad types of energy, I thought it was really quite interesting that this is how she phrased it. Then she also said that it's different from just being given some kind of data set when it is the data set of the school that you're working on. She says that motivates one, and it motivates you to engage in your classes more. It's windy. Yes. So this was the first project I was involved in, but I just wanted to end by giving some perspectives which are more on the vocational side of things. So this was a high school, but I just, as I mentioned, just came back from Amsterdam, where I helped Svendborg Erhvervsskole, so Svendborg Vocational School, which has a maritime focus, to apply for some funding so that they could send their teachers on a teacher's training in Amsterdam. This week in Amsterdam was the Electric and Hybrid Marine Expo and Conference. And well, this is basically, to me, we know these conferences, right? It's about batteries, it's about the storage solutions, the control systems for batteries, and so on, just as we've had it in the automobile sector, but now it's coming to the marine sector. Of course, there's also focus on alternative fuels, so not only battery-driven, but also liquefied fuels. But the primary focus was really on electrifying the marine sector. So they were extremely interested. I had this small group of dedicated teachers who teach ship mechanics and electricians and other skills around the maritime sector. And on the picture on the right, we visit a garage, literally a garage in Amsterdam, where they develop an autonomous electric boat that will also supply as the system to a French Paris-based ferry system, which will run autonomously if it is allowed to do so. So it's the same challenge as in autonomous driving in vehicles as well. And on the left-hand side, you see that we get a demonstration of a battery system, which is produced by Leclanché, which is one of the big producers in this field. So this is just one way where education for sustainable development really has a hands-on focus. And I was surprised that even the conference organizer asked me, but why are you bringing teachers to our conference? And I said, well, but everybody else goes there because they need to update their skills and update their knowledge. So who would be more relevant than teachers to go there, because they are teaching the next generation of ship mechanics and so on. And it really seemed like there was no tradition whatsoever to bring new knowledge of this kind to the teachers. So in that sense, it seems that this was an unusual step to take, but I was very happy that we were able to do so. Another direction that another project that I'm working in right now. Oh no, you can't see the cow. This was supposed to be the funny slide with the cow. Yeah. Is with Kale Organic Farming School, so Kale Økologisk Landbrugsskole, which is also here in the peninsula of Denmark. They want to focus more on integrating solar and food production. So back to the comment that Anja made, that at the moment for farmers or for anyone with a plot of land, the best business model is really to get the permits to have solar on it, put solar on the field, and then basically stop food production. So you already see that the land prices are increasing. The value of a piece of land where the permits are already given is double or threefold compared to a piece of land where there are no solar permits yet. So there is a strong rush, a kind of a gold rush in this sector. And I think it needs some more sensibility for combining agricultural production with solar instead of having this conflict between the two. So the concept of agrivoltaics is that these two things can be combined depending on where you are in the world. Either you protect your land from strong winds, that would be the most relevant one in Denmark with vertical systems like in the right-hand side panel, or in southern Germany, for example, you protect your fruit trees against hail, which is the middle type of system where you have a solar installation which is quite high up. I guess it makes it more wind sensitive in that way, so there's a trade-off there. And the horizontal one, which is also lifted high from the ground, is also typically used with crops that are that like shadow. So not the most traditional corn or grains, but more for smaller scale food production. This is the the vertical installation, which has just been opened at the Research Center for Agriculture here in Denmark, in Poulsen. I was there at the opening a few weeks ago. And this is the type of installation that this agricultural school also wants. Unfortunately, yeah, these are a few Danish media outlets that write about how you could use agricultural production and solar production on the same field. And we have similar headlines also. Wait, I think I skipped that slide in my slideshow. Anyways, you have similar headlines internationally as well, where people are starting to realize, okay, let's integrate the two technologies. But of course, it has a lot of challenges, especially policy-wise. It's not very clear what the legal framework is for this. And I'm actually quite afraid that this organic farming school will not succeed in getting the permit, because if you go back to this picture, you see that they're located in quite a beautiful area. Now this picture is taken toward the forest. There is plenty of agricultural land around it as well. The problem is rather that they're close to the coastline, which means that they told me that even planting a tree required a permit. So they're not, it may be that the first school who wants to teach about agrivoltaics to new students, not just at university level, but before that, will not be able to do so because of permitting issues. I think it's, while at the same time land is being grabbed all over and completely taken out of agricultural use. So I think there's quite an irony in that. Oh yes, so just at last, of course, this has this integration of agriculture and photovoltaics has benefits regarding the total dual production, but it could actually also be seen as beneficial from an energy system point of view. This was a study made by some German researchers using the Aalborg energy plan model, where they tried to simulate how would the impact on the energy system, the electricity system, be if you use these these vertical installations. And just as the east-west installations on roofs, it can have a beneficial impact because you don't have this noon peak, but rather a morning peak and an afternoon peak of electricity production, which helps to smooth out the production over the day. Yeah, so at last, energy for education is really about interdisciplinarity. It is about, well, the second word is like a Danish educational sector buzzword at the moment. I would translate it as something like action competence, like you learn not only what to do, but you also learn to do it. You have an action component in your education. Systems thinking, we all know that that is important, especially with systemic change as the energy transition. And then last but not least, having the more science-related subjects, so mathematics, informatics, natural sciences, that's this abbreviation STEM in Danish. Having those subjects in focus and showing how they are relevant for this concrete task of the energy transition hopefully also means that more students are attracted to these subjects. At the moment, it's quite difficult to attract people to the more engineering and natural science type of studies at, for example, high schools. Yes, so that was all from me.
Thank you.
Yeah, thank you.
Are you ready for some questions?
Yes, definitely.
Yeah. So first thank you to you, and then I will ask if somebody wants to ask Kirsten about it. Kirsten, how long will you be with us?
Well, I was planning to be here for the dinner as well.
Yeah.
Yes.
We will have Kirsten stay also when we stop this presentation. Okay? Yes.
Okay.
Var du også med, Lisa? Du så i dig? Ja. Så kom bare med. So please, Lisa.
Hvad skal jeg lægge i det top for transport?
Nej, du vil jeg tog det. Okay, so Ruth, please.
Kirsten, thank you very much. I'm very interested in that. It looks like, financially speaking, it is so much into Europe.
Yes, I'm only working with Danish schools. Yes. Not even just Europe, but only Danish schools. Yeah. Yeah.
Okay, so because in Africa, some countries definitely are also trying very hard to work on energy and to educate or create awareness in schools about energy.
Mm.
So, but the two levels are very different. Probably we'll talk after I've taken your email
Yeah.
and see how the possibility of helping the lower level as far as the one in Denmark is concerned. Because globally we all need to be somewhere in terms of energy development.
Yeah.
Yes.
Yeah. No, this was simply a matter of where I found access to working with schools at all. Yeah, and I found the easiest access with the Danish schools. Yeah.
I lost my train of thought for a second. Now I found it again.
Okay.
Because I really like what you're doing. It's good to see you again. And it's very important, not just, it could be any energy type, because they learn something about where it comes from and how we use it. This, of course, solar is a lot of fun. I like solar PV a lot. Are you also, do you think it would be as easy to have an education on energy savings? Because that's also very important that we not just consume more, it helps more to consume less.
Yeah.
Do you think that people are interested in that message?
I do think they are, but focusing on the data or having some kind of timelines where you can manipulate some data, it was easy to start with electricity. Not even heating either, which is a bigger issue and would be just as important to work on. But once the students are involved, they will frequently move into other directions, not only focusing straightforwardly on electricity, but for the operations of the schools, what is the biggest change that's happening is that they are restricting their travels, for example. So many schools are not flying on their study trips, but this goes only for the students, for example. So I took the train to Amsterdam, but the teachers, they were flying in. So there's still some way on looking at the overall reduction of the footprint. But I think material consumption, which is quite big in the vocational schools, and traveling, those are maybe two areas where you could quite concretely work on reducing the overall energy need. Yeah.
So it seems that no more questions, and we will thank Kirsten to come to us. Thank you.
Yeah, you're welcome.
And then I asked how long is
three we have known for many years here in Folkecenter. But especially Arne, he was very, very young when he arrived Nordic Folkecenter. So, but maybe you'll say a little about that also.
Later on. Yeah.
Okay. So please, Arne, take the
yeah. So, hello everybody. My name is Arne Jaeger. I'm from Germany, from Düsseldorf, and I'm currently the manager of the German Wind Power Museum. As far as I know, the German Wind Power Museum is not very familiar in Denmark. So the intention of this short presentation is to give you all a rough impression of what this facility is all about. Yeah, that's what we're going to talk about. Let's start with the key facts. Originally, the museum was founded in 1999 by locals who were involved in the wind industry in the municipality of Stemmwede. Some were representatives of Danish German Nordics, and some were representing the famous Danish manufacturer Windworld. And a farmer had the idea to create a small museum. The point is, until 2015, approximately, the museum remained very, very small and comparably unknown. So that's one reason why many people outside Germany simply don't know it. We currently have about 200 members. Of these 200, 5 are regularly working on the museum. We currently have, in fact, the world's biggest collection of wind turbines, approximately 40 in this year. I remember presenting the Wind Power Museum to you for the first time last year in December when I came here. And I remember showing you that huge catalog that I had created. And the first sentence you said was, well, this is definitely the biggest I've ever seen. It's even bigger than the Folkecenter collection. On the other hand, I want to emphasize that we don't consider ourselves as competitors to Folkecenter, but rather as friends. What is special for us is we do not only stock and exhibit commercial wind turbines like Vestas, Nortank or Micon, but we also exhibit homemade wind turbines which have been produced once and are totally unique. So, the geographic location of the museum is here. We have the Ruhr area here, Bremen, Hamburg, the famous Hannover Fair, and we are situated right in the middle between the A1 and the A2. We are approximately 1.5 hours away from the famous Hannover Fair, more or less, 1.5 hours, and I can recommend you to use a car to come to us because public transportation is a bit difficult in our area. It's very, very rural. More key facts. Yeah, homemade turbines are included and wind turbines from altogether 7 nations. Germany, of course, Switzerland, the Netherlands, Denmark, of course, the US, France and the former GDR, the German Democratic Republic, which is also known as East Germany. A fun fact maybe from the turbine owner from the GDR, he was a homemaker, and he had to take 10 years, according to him, to build his turbine, and the reason was the plant economy in the GDR. And I once visited him and he said, well, we had nothing. We had no concrete, we had no ideas, we had no steel, we had no anything. He started building his own turbine in '85 and he finished in '96. Yeah, incredible. In '22 and '23, we managed to receive state funds and EU funds, giving us more option to develop our premises. And we are currently working on getting more money for the next years. So here we have a list of all turbines currently on our premises. It's about 41. What's most interesting for you could be the Allgeier, which roots back to 1955. Alternergy Aerostar 7.5, a huge commercial success from Denmark. A huge collection of Enercon machines, ranging from 55 to 500 kilowatt. We have an American Kenetec, which was the former United States wind power. Kenetec became famous in Germany for collaborating with the American NSA to get secret information from Enercon. It was a huge scandal in the industry in 95-96. Kenetec went bankrupt the same year. What else could be interesting is the first Lagerweih that was installed in Germany in 1982, a Dutch machine. We have the famous Aeroman from MAN, from Bavaria. Many homemade turbines, as I've already pointed out. 2 Nordics machines, N27 and N29, that also incorporate the integrated drivetrain developed by Folkecenter. So we kind of have Folkecenter roots on our premises. We have the Berlin Südwind. We have a medium-sized and huge 1.5 megawatt Tacke. Tacke was a big German company from the 1990s, 80s and 90s, and was always considered as the big competitor to Enercon. Enercon and Vestas were the 2 big Germans in the 1990s. Tacke is today General Electric. Enercon still exists as a family-run company with 12,000 employees. Windkraftzentrale Elektromat is very interesting because it's based on the Danish SJ, which started in the 1970s. It was a windrose. So as you can see, it's quite a lot, ranging from 1955 up to 2000. What do we want? What are our goals? To put it in a nut, we want to save as many turbines as possible. We want to keep, honor, and demonstrate the roots of modern wind energy to the public and create more awareness for what people did in the past. And of course, we support wind energy in general, as a matter of fact. So, here we have a rough impression of our store, as we call it. This is an outer part of the museum. It's about 300 square meters, and this is where we stock all our turbines. The very first thing we always do is save the machine from getting scrapped. And then we store it here, and when we have a final place for it, we put it up on ground level, just like machines were displayed on fairs in the 80s, 90s, and zeros, to give people an impression and to give them a hands-on experience. This year, we are redeveloping our entire premises. So what can we see here? The entire facility is built around a single farmhouse. We have a land lease agreement with the landowner. This is the place where it all started in 1999-2000, and we are converting this place to a sort of experience center, which I will explain in detail later on. Here we can see some more stock parts. This picture is about 1 year ago. What else we can see is an existing Nordics N29 here and here. So we have 2 big nacelle wind turbines as sort of landmark, a sort of orientation. This garden part is supposed to be converted into exhibition space for the homemade turbines. It was my idea to give them a separate space because homemade turbines, commercial turbines, shouldn't be mixed. It's too special in my view. Here we have the original access way from the official street to that Nordics machine. This access way will be expanded to both sides for creating additional space for all commercial turbines, like Enercon or Vestas. By the way, we got Vestas #2 in whole Germany, #2. from 1987, a 75 kilowatt machine. And here in the back, we have a separate space for the blade exhibition that I'm working on right now. Wind turbine restoration is a huge part of our activities. We managed to get state funds by the government of North Rhine-Westphalia for restoring 5 machines. The first Lagerweih from 1982, a Krogmann 50 kilowatt. Krogmann was a company from Lohne, Kroge, which is located very comparably close to us. NEW, Neue Energien Wiengebirge, was a local initiative that will be presented by us as well. The Berlin Südwind will be restored, and the Bavarian MAN. Lagerweih and Krogmann are already done, and we are now working on putting up NEW and Südwind machine. One aim we had to fulfill was the demonstration purpose. The purpose is to demonstrate technical details for educational purpose. For example, blade pitch mechanism, actively or passively, blade tip mechanism on the older machines, tail vane yawing, which we can see here on the test site, and active yawing, which applies to almost any turbine in the whole world. So, on January 3, I managed to install our restored Lagerweih. So here we have a concrete foundation. This is the restored nacelle. Heaven Blue is the official color name. I had to recut the internal threads because the restoring company put so much color on them they were unable to use anymore, so I had to recut it. Here we put up the generator. These 2 blade parts are not cut blades, but artificial blade parts in order to save the originals. And to demonstrate that this is a 3-blader and not a 2 or 1-blader, because some people simply don't know. They see 1 blade, it's a 1-blade machine. No, it's a 3-blader. Yes, some people simply don't know. Huh? So on March 2023, we were able to demonstrate the passive pitch mechanism of that Lagerweih. You can see here my colleague. He is pushing a metal pipe adapted, bolted to one of the blades. And by means of physical pushing, you can simply move all 3 blades and demonstrate the passive blade pitch mechanism. And the muscle force represents the wind force. So here we can see the restored Krogmann. That machine was fully restored and presented for the public with 2 viewing holes. It was done by Vensis in Diepholz. These 2 blades from Dutch company Prince Fibertech were restored by a separate company. And with this machine, which is not yet fully done, we will demonstrate the active blade pitch mechanism. So by pushing a knob, the blades will turn automatically. Blade exhibition. The blade exhibition is a separate project that I'm fully responsible for. It has also been funded by the state government of NRW, and the aim is to demonstrate all these tons of various blade designs, blade companies, manufacturers, periods, countries, and whatever. I hope to have finished that huge project within the next 2 months. It will take some more time, but I'm quite positive about it. So, you remember one of the existing Nordics machines? Here we have that new piece of land covered with plastic foils, and many rotor blades have already been put into position in a chronological order. You can see here the transportation of an Öker 5 meter that was previously mentioned by Katherine Dykes. Öker 5 meter blade has a huge connection to Folkecenter and the Smedemester blacksmiths turbine. That blade set was not used in Denmark, it was used in northern Germany by a private man who built his own turbine, but who bought Öker 5 meter in 1981. The famous founder of Enercon, Alois Wobben, who passed away 2 years ago, he built 2 homemade turbines before starting his own company, and the second machine also used ÖKER 5 meter, so that blade really has a pioneering character. This is the MAN blade. This is me, by the way. Here we have a huge blade that was built by MBB, Messerschmitt Bilko Blom, 23 meter long, 1.8 tons heavy. Here we have a blade with a blade spoiler mechanism from a homemade turbine. And what I'm currently working on are these metal stands that keep the blades in position. I have a little shop in my garage at home, and maybe you can imagine the whole garage is full. No car fits in currently. So, here we have a closer look at the blade exhibition a few days ago. So, what can we see here? On the right, we see a blade from a company called Born. Friedrich Born was located in northern Germany and built blades from 1985 till 95 approximately. Carnot was a German company, a pioneering company from northern Germany. Windforce 5 and Windforce 7.9 are the successors of KJ, Kai Jensen, a Danish pioneering company. KJ and Windforce blades were also used on the Smedemester turbine. A&R is Abeking and Rasmussen, was a huge German blade supplier from the 90s. HSW is Husumer Schiffswerft, Husum Shipyard. MAN is the famous truck company from Bavaria. Aeroman was a German pioneering product from the 80s. Stork was a Dutch company, very successful blade manufacturer, who also supplied to Danish Nordtank on the 75 kilowatt. And of course, the very famous and super successful Vestas 8.5 here. It was Vestas' very first own blade development. It was used on V16, V17 and V19 from 55 to 90 kilowatt, and 5,000 or 6,000 units of this blade have been produced by Vestas. Here you can see the metal stands keeping the blades in position. Another closer look at the blade exhibition. On the right, the super successful and super famous Aerostar 7.5 was the most successful Danish blade of the whole 1980s. More than 10,000 blades have been manufactured. Aerostar 7.5 was used on almost any Danish machine of the 55-65 kilowatt generation. Vestas, Micon, Nordtank, Bonus, whoever. The interesting fact is that these blades that we got were allegedly used on the very, very first Enercon from 1985. The point is, the labels have been removed, so I can't check. But I have a different option, so maybe we will find out later. Here we have two homemade blades. You can easily see the difference. Commercial blade and a homemade blade, totally different. To show these differences is our goal. Here in the very front we have an American blade by American pioneering company Berger. As far as I know, you had a Berger on the test site here, no? Yeah. Here we have the ÖKER 5 meter, late 70s, early 80s. Stork Clava 10 was applied on very, very early Lagerweih machines. And the Allgeier metal blade roots back to the 1950s. Here we have a list of all blades on our premises. Abeking and Rasmussen, that huge German company, a huge fraction of homemade turbines. American Berger, alternately Allgeier. Enercon blades, very important. 4 LM blades from Danish super rotor blade giant LM, Lundesco Möbler. MBB, our biggest blade, 26 meter long. Ilkir, prince from Denmark, prince from the Netherlands, Stork, Netherlands, Südwind, the famous Vestas, and the INFORSE blades, of course. Another thing we are working on is environmental education. We offer physical experiments to local schools, high schools, whatever, and to give kids and teenagers an approach to wind energy, an approach to renewables in general, and to at least try to avoid disinformation of any kind. We all know about the internet and its problems, creating any sort of disinformation in every minute. Renewables and wind energy are affected as well, and we're trying to hold against it. We get regular visits, 2 visits approximately a month, from local regional schools and sometimes from universities. Yeah, and that's what it looks like. We usually get kids and teenagers in our huge room and on the fields. And yeah, very funny, very sensible way to promote wind energy in my view. Yeah, thank you for this.
The catalogue that you bring last time you were here in December, it's up in our table where we put the newest book. So there it is when people want to see.
Okay.
So was there any questions to all the things that are in the Technical Museum? Yes, please.
I actually have 2 questions.
Please.
First one is how do you attract the public to the museum? So how do you reach your public?
Yeah.
And the second is how do you display for example, the blades? Do you have panels explaining the differences, or you have a guided tour, or how do you?
Yeah, question number 1.
How do you differentiate between this blade and that blade for someone who doesn't know anything?
How to make clear about all the differences.
Yes.
Yeah. Question number 1, what do? We have a good connection to the regional press. We have a website that I'm responsible for. We do not use social media because of all the difficulties that might come with it. We often talked about that, but for some people, even for me, it's a difficult issue to use social media because you might end up in a disaster, and it's not what we want. As long as we just have our website, we keep control of the digital content. Another point is that there are people who, in the area, there are people who really hate wind turbines, and we even have to fight these people. They hate us, you know what I mean, the very old conflict, and we don't want to give these people an opportunity to kill us through social media. That's what we do. But we have a good contact to the local press, the regional press, we have the website, and I have a good contact to the industry or to important people in the industry, for example, Folkecenter. The second thing is I'm currently working on a separate catalogue, an accompanying catalogue to that blade exhibition. It takes a lot of work, a lot of time, but I hope to have that finished somewhere in autumn. And that clearly demonstrates all differences of all the blades, all these 25 blades that will be exhibited. Yeah.
I have a question.
Yeah.
Where do you get your machines from? Do you buy them on second-hand market, or how is it?
Yeah. I was responsible for about 50% of the entire collection. It means 20 machines. I started that activity in 2013 already. What we usually do is, I know many people in northern Germany who might be interested in getting rid of their old machine, not scrapping them, and having them displayed on the museum site. And I have many personal contacts, and from time to time I use these contacts, and people are usually very happy to have the machine not on the scrapyard but on the museum premises. What we do is we have a 20 tons truck someone who drives it, and I can't, unfortunately, though I'd like to. The decommissioning of the wind turbine is usually done by the owners because it's their interest for various reasons to get rid of it, and then it's simply loaded onto the truck and we do the rest. That's how we do it. So, to answer your question, it's all about private contacts. And I know many people in northern Germany. I think that's enough. I have 5 more machines in the pipe for this year and next year, even in the Netherlands. I think that's enough. Yeah.
So,
yeah, yeah?
Do you get any economic support from the government or your municipality?
Yeah, from the state government. Not from the federal government, but the state government. Yeah, and we applied for EU funds, and we won a contract on a small level. Yeah, that's how we sometimes get private funds as well, but private funding is a bit more difficult for various reasons. Sometimes people donate, sometimes they don't. Depends. Anybody else? No. Okay.
Then Manny, thank you, Arne, but you will be here still, so we have to do the next in the program. Sorry that I take up another thing. The paper that are turning around, it's okay, and you have to turn like and then we talk. Good. Now here for our, now we have been here 40 years in Folkecenter, and we have get different gift, art gift, and so. And we also get one art gift from Arne Jaeger, and we will show it to you now. We have put it because you come today.
Yeah, of course, yeah.
And then you should do it. And it means that I need to have 3 minutes to help me. So it's quite good. So Arne, will you help me? Come on. And and 3 will help. Come on. So that's very good.
Panoramic camera. These black and white shots were made on film. They're not digital, but film. I used Kodak black and white film, and the original negatives are that big, 6 times 17 centimeters. And that huge amount of quality creates all these details. So if you get closer, you will see anything related to the turbine. No pixels, no grain, no anything. And I personally thought that these 3 pictures clearly represent the meaning of the twin turbine and the character, the appearance of that turbine. and we thought that this day today is the best to demonstrate it. Maybe you would like to say something?
Ja, altså I will, altså first of all, I get it from you, we get it from you in Folkecenter.
For free.
Because, because you want that we could put it here. And then I asked Arne if we could take the last one that I get for not so long time ago, and then we make it as a presentation today. And Arne accepts, so it's what we are doing now. And then I will ask you, Arne, will you say a little word about how you come to Folkecenter?
Yeah, exactly.
Yeah.
Let me have just one more thing for you.
Okay. Chocolate.
I always got something left.
Yeah.
So, what I have here is another black and white shot of Hans Hvelplund, the original, not the best of turbines, but the originals from 1996, 95, 96, that Folkecenter is technologically related to as well.
Yeah.
So,
that is very important.
The first time I came to Folkecenter was in 2000.
2000.
So, in 2000, 23 years ago. I was 11 at that time. This year I celebrate my own 30th anniversary. I've been privately involved in wind energy since 1993. I started at the age of 4, and now it's turned 30 years. So Folkecenter is 40 years, and I have 30 years. And maybe let me just give you a personal note. There's a lot of positive things that I remember. I remember the first time I was here. I remember the initiative my dad took in 2003. He went to Jaeger and talked to him, and that was the first time that we also got in contact. I remember the first time in 2004 when I stayed here for a week at the age of 15. I remember when Frede asked me to take part in that huge book from 2013. I remember the publication of that book in 2013. I remember very personal and encouraging talk that we had when my father died in 2013. And I remember many other positive things. So the point is that in this world, nothing is for granted. Absolutely nothing. Not even please or thank you. So after visiting Folkecenter for about 18 times in 23 years, I'd like to say to you, thank you for everything.
Thank you to you. And Helena, where do you think we should put it?
I don't even know what it
So,
looks like. Everyone point, and the place that has the most fingers will.
You see, you see, first I have to have a discussion with Bjarne Nyborg. What should be moved away? But that will be my responsibility, that I will take this discussion. So now we have to put it back again. And we need the blankets because it's a very heavy picture, and we have to take care that it not scratch each other